see them. Every person, every enumerator sending in the data will be listed here. So if you can preview that particular questionnaire so that you can see the content of that particular questionnaire, what the enumerator has filled in. There are these features. These are in table format. There are reports. These are brief reports or summarized reports on your data. These reports cannot be used as final data unless it has been analyzed and then a final report is given. As it is being indicated here, these are automated reports based on raw data. So if you want to check on your progress on data collection, you'll be able to check from here. That is monitoring the collection of your data, monitoring the enumerators. So you can be able to see this guy has sent in 36 forms or questionnaires. The other one has sent in 36, the other one has sent in 31, because if they have targets, that means you can be able to monitor them here. For the gallery, these are the pictures which has been taken in the field, and now they have been uploaded back to the server site. So you'll be able to see the photos, maybe for the farms and maybe homesteads, if it was depending on type of survey you are doing. So on download option, this is where you download your data. So once you have completed the collection and uploading of your data back to the server, you can be able to download the same data so that you can go and clean the data. At the same time, you can also go and analyze the same data. So download can be done in form of XLS, that is Excel format, CSV, and all these formats. SPSS labels, SCSV, and all those. So, but normally what is being used is the Excel format because of ease of integration with analytical softwares. For the map, you'll be able to see in real time where these people are working, the enumerators and the respondents. If you want to know where that data was collected, if it's an exact location of where you know, if you have maybe replication sites, and you want to actually know if your enumerator went to the site, or they just went to the road and collected, fed in the information, and say they have collected data. So you can be able to see, pinpoint that exact location where that data was collected. So here you can be able to view the name of the enumerator. You can disaggregate the same data using the name of the enumerator or the respondent name. So if you want to know who was the respondent, you'll be able to pick it from here. Sorry. So so in this regard, you'll be able to monitor everything going on during data collection. And if you want to know if your areas are covered well and the sampling is representative, this is where you will monitor that particular collection of data. Because at some stage, the enumerators may be going along the road, collecting data on households along the road because of ease of access. But at the end of the day, that particular data may not be representative because they are coalescing around an area. So for data to be representative, I'm sure you have heard, it should be like in a dispersed format. You collected randomly. So if they collect in a local area without maybe walking all through, it means that data may not give you the right picture of what you want to analyze. So I think.
Is that it?
So that is it, Dr. I can end it there.
Yes. I think
So,
it's sensitization.
Yes.
Sensitization. There's a lot that are new and making our work enticing and conforming with the other parts of the world. Sometimes if we can go even be ahead of the other people, they can learn from us. So I want to welcome questions. I want to welcome questions to Victor. How do you do that? I want to see the hands. I've clicked. I maximize. Are there reactions? Can I see some hand? I can see one. Mado. Any other? As I say, this was just like eye-opening sensitization. I think many of you are already aware of this ODK and how it can be used, the way Victor has ended with even monitoring the quality of data collection in terms of representation. We give a clap. Ruth is good. We give an applause to Victor. Victor, excellent. And
thank you very much, Dr.
Yeah. So, Mado, can we get your question?
Yes, Dr. Thank you, Victor. This was very, very important for me. I would like to ask if this is applicable to my area. This is soil sampling. Is it possible if I send some staff people to a field somewhere to do some soil collection, that is sampling, then I can monitor from the laboratory? Is it possible using the servers you explained? I want to see the applicability.
Thank you.
Just note, Victor, I believe the answer is yes, okay. And you can expound, but let's see any other question. I'm seeing only Mado. Any other second question? How many people are aware of this ODK? How many people have experience with it? Can I see it by a show of hands? The people who are conversant with it, by a show of hands, I can see Mercy. Yeah, the numbers are swelling. It's now 6, 7. If they reach 10, I can assume good representation. ODK, people who are aware of it. Now, amongst you, Cynthia Nekesa, can we hear from you, Cynthia, how you have interacted with this ODK? Cynthia? Cynthia, can you come on? Or any amongst you who can offer? The hands can go down so that I remain with the only hand that somebody who can make a comment of their experience with ODK. And here I have Cynthia, the hand is still up, and Emmanuel. Emmanuel and Cynthia, can you give some comments on how you have experienced ODK? Cynthia? Emmanuel, any of you can go on.
Yeah.
That is who, Victor? Emmanuel.
Emmanuel, okay. Emmanuel has asked if someone has turned off his or her network connectivity on the mobile device, if he'll be able to be located or tracked. Yes, it's possible because the GPS actually does not require internet for you to be located. So the application uses the GPS. So once you pick your GPS, we will be able to track you even without the internet connectivity.
All right. Victor, you can check questions on the chat wall, but Cynthia, your hand is up. Can you ask your question or a comment?
Not asking a question, it is Cynthia.
Yes.
I was commenting on you've asked those who have been able to interact with ODK.
Yes.
Comment something. Personally, I've interacted with ODK during when conducting mostly household surveys.
Yes.
And it has been a very efficient tool, and it really saves on time.
Okay, Mado, you can see you love this. I don't know whether there will be.
There is, Daktari, there is someone who has asked, how do you determine the sample size of a survey?
Yes.
So the sample size of a survey, this is the design of your form now, the design of your questionnaire. So it means
but that bit has been covered. I don't know, he has asked it in what context. There are other people, Professor Ward gave a very elaborate, even formulae of determining the right size of the sample and all that.
The sample, yeah.
So
exactly.
I don't know whether ODK is just a tool. It's just a tool. Instead of having your notebook, you are now having this software to help you collect information. But as to what sample, I could say that is in your own experimental design, which you have written it in your proposal and that has been approved. And you have shared with your whoever, your partners or supervisor, and they have approved this is the right way to go. But Victor, you can still add if you want to say something.
Yeah, it's okay, because I wanted to say exactly the same way you have said that this is handled during the formulation or design of the questionnaire. Because when you are designing the questionnaire, it means you are working with a person who is now knowledgeable on the sample size to be covered and all that. So what ODK does is only to take the designed questionnaire onto digital format for feeding in the information or data.
Yeah. So check this chart if there are things that they are just compliments. I can zip compliments. I
can see a number of compliments. Now, maybe if as they continue chatting up or writing their chats, one thing I wanted to add is on collection of data in the field using the mobile device, the ODK application and the ODK application. The people who are going to collect your data or the enumerators must be people whom you are knowledgeable with or who are trusted, because there are some people who are crooked. If you get anybody to go and collect your data, the people, the way the culture in Kenya, people like shortcuts. So there is a scenario which happened sometimes back, whereby some of the enumerators who are assigned to do some tasks or to collect some data in the field, instead of them, because I don't know, they were tired or they did not want to walk around the households to collect those data, they went to a Safaricom agent and they photocopied their book, which contains the names and the mobile numbers. And what they did is to walk around now and filling in the information, the names of the people, they are non-existent in the ground or on the ground. And then, you know, what they were doing is just to walk to different locations around the place. So you will see that, okay, he moved like for 5 minutes, he captured another questionnaire. He moved like for 6 minutes, 7 minutes, he captured another questionnaire. So at the end of the day, they will say we have done around 10 questionnaires or 15, which are all fake. It doesn't have the data you want. So it's very crucial for you to vet those people you are using to collect your data. At the same time, what is crucial also is monitoring of that particular data on the portal, the way I've shown you, so that you can be able to know the location where that data is being collected. At the same time, you also know, you look at the content of that particular data so that you'll be able to see what has been collected. Because you'll be able to see as the exercise goes on, you'll be able to see the real data coming in. So if you see like some data on value chains you are targeting are not coming in, maybe they are now giving you data on other value chains, it means those people are doing their own things in the field. So you need to call them on their, because the mobile numbers, you have their mobile numbers on that particular form, you'll be able to call them and ask them what they are doing and that their data is not valid. So because they are being paid per day, the enumerators, for collecting your data. So it means if you remove some data, maybe you had targets of 10 questionnaires per day. So if you remove those bad data, you may remain with like 3. So you'll pay them as per that particular good quality collected data. So that is my emphasis when you are collecting data using this ODK.
Yeah, I think that's a very good precaution. I think you said it's Kenyan culture, and some of these things, we go to church, we get a lot of counseling, and still they linger with us. I believe the researchers, as you've heard, if you are to use this ODK, put some kind of measures that can ensure that your data is appropriately collected. You may need a photo of the farm and a photo of the farmer. You may tell these guys that as soon as you reach there, you call me back and I greet the farmer. I do the first part of the questionnaire, and then you carry on. That may be a way of ensuring that these people are actually talking to the right person. Right?
Yeah. Hello, Doctor, I can see two questions.
Yeah.
I can see some
yeah, you can put okay, just go on and explain.
Okay,
let Victor, Kevin here say, then Victor, you will crown it. I want to give Kevin a chance. Okay. Kevin, unmute mine. Kevin is talking.
Yes, just in addition, also in the questionnaire, you can add a field of the photo where a numerator can take a photo of the farm or of the farmer. Yeah.
It's one way of ensuring, and I saw in Victor's presentation of assuring, and I saw in Victor's presentation that some of the fields were having photos of the map. Yeah.
Yeah, it's true. You can design your questionnaire so that you can pick photos of the experiments or the target area you are doing. The way I had shown you the coloring on photos on the bottom. So there is someone called Robert asking whether collection mainly on yield using whether ODK enables data collection mainly on yield using digital scales. Robert, yes, it's possible to capture that measurements you are doing in the field, so long as you have designed your form to capture the same. So you'll be able to use the digital scales in the field, and then you capture the data you are getting onto the ODK. And then we have Mercy. Are you able to access real time as they are being collected, or you will wait till the end of the day? Mercy, as I had shown you on the portal, you will be able to monitor the data coming in real time. So if you want to see it minute by minute, you will be able to monitor and follow or make changes where possible as the data comes in. So you'll be able also to monitor the respondents in the field or the numerators as they walk around the field. You'll be able to see it from that portal I showed you, the map. So I don't know if I have answered the two questions well.
Let's give Victor a round of clap, and we close the session. We go for what I termed early lunch. It's not really very early now, and be here at exactly 2. What I'm seeing is that we cannot afford to carry on today's work for tomorrow, because tomorrow will be just for proposal writing. We have to start this way because I believe proposal writing will borrow a lot from what is already covered in terms of the content. And I want the remaining presentations, Mudeheri, Professor Owoche, and Professor Owor, let us, and Dr. Mondi, if he'll join at the point of conclusion recommendations, let us try to summarize this, get an approach in which within 1 hour or 2, we will be done with this at the maximum. And Susan, Dr. Susan Otieno is in Malawi at the moment, but we are in contact. So she will give us some ways of citations, writing citations. Yeah, the acknowledgement part I'd already covered yesterday in a small way. It's not a big part of the scientific paper. And I think, so that at the end of the day, we want to finish what was meant for today. We want to spend the last 1 hour by around 4. We want to have Dr. Purity. Purity will cover the plagiarism. Choice of journals is inferred to some extent. Is not the greatest thing that we may fail to we can think that we may not have to miss, but we'll try. So Purity, are you on? She was there in the morning, but maybe she has logged out, but Purity will be there to give us some issues. You are there, Purity?
I have been in the whole morning, yes, and I have.
Yes, Purity, I'm very happy for that. So we will have you towards the end of the day.
Oh, okay.
Yeah, towards the end of the day as we wrap up.
That's
but
okay.
I want to release you now for 1 hour break. If you are physically going to have lunch, or you just stay around to digest what we have gone through, then at exactly 2, we start. Don't be locked out. I see the 100 is the maximum. So beyond that, then some people fall into the YouTube. Eh? Yeah.
Thank you. Maybe just in case Victor doesn't come back, thank you for exposing to us as learners and scientists and academicians the tools.
Yes.
I am currently experiencing the ODK. I like learning, so I was learning on ODK, and I have a PhD student who is using that, and I'm happy with the insights you are giving, because then we can look at that. And also the Cobot toolbox, I also have a second PhD on that, and thank you very much for the insights you are giving. It is a new technology, and we have to keep working at it. Thank you.
Thank you for the compliment. Yeah, so do we close it at that? And we come back at 2. At 2, we will be on. Thank you. So young man. That's okay. So let me work on this guy. Ladies and gentlemen, welcome to the afternoon post-lunch session. I want to welcome you, hoping everything is okay. Is Maurice on? The resource person, Maurice, if you are on, I know you had some carryover, a few clarifications that were said to be clarified in the results section. So we'll give you the opportunity to begin this afternoon, and then you will be followed by Professor Owoche, and then there will be Professor Owor after that. And maybe I will come in if in case, just in case, there will be need to clarify some issues. So let's give Dr. Mdaheri, I don't know how long, if you can take 10, 15 minutes, it will be okay so that we save time. So, Mdaheri. We have some challenge here. Power has just gone off. So we are trying to use our mobile devices. I don't know whether they will be efficient. So you will bear with us, but I hope they will. So Maurice, set up your Nini properly screen. Tilt your screen so that we can see you.
Let me prepare first.
All right. There's a lot of light behind you. I don't know the effect of the curtains. Not much difference, but let's go on.
Are you seeing me or?
We are seeing you, just tilt your towards you, Kidogo. No.
Like that?
Yeah, that's okay now. Now share your screen.
I've shared, but I'm not seeing myself.
Have you shared? We are seeing you, but not the screen. Maybe it will come. Yeah, there it is.
Okay.
You can give your narratives.
Yeah, I wanted to start with somebody asked about data transformation.
Yes.
So I wanted just to talk a bit about it.
Yeah.
There are some data when you want to report or analyze it, they need to be transformed. So there are three main methods that are used in these. This kind of transformation. There is the first one, logarithmic transformation. And this one is normally applicable when there is heterogeneity of variances. Standard deviations are directly, in such cases, 2 or more instead of an additive effect. You're getting me?
The sound is a bit breaking, but go on.
So there is, first of all, the logarithmic, where somebody can check for heterogeneity of variances using the Bartlett test. And that one can warrant the transformation using the logarithm equation. The second transformation that normally people use is the square root transformation. This one normally applies where group variances are directly proportional to the means. When data are like counts, you can use this square root transformation. And the last one, which people also use, is the arc sign transformation. When data is from binomial distribution, this one normally is reflected when you have proportions of percentages. So those are the 3 transformation methods that can be used in different instances when a transformation is required. But first of all, you check for normality of the data before you can decide which kind of transformation can take place. But in most cases, when you have counts, just use the square root transformation. And when you have proportions or percentages, you can use the arc sign transformation. After the transformation and you have analyzed the data, you can revert back to the original form of the data for your reporting. The other thing somebody asked was about the power of a test. The power of a test. The power of a test. In hypothesis testing, there are 2 kinds of errors which may be committed. If the null hypothesis is rejected when it is true, that means you are wrongly rejecting. Then a type 1 error is said to have occurred. If the null hypothesis is not rejected when it is false, then type 2 error has been made. So in probability terms, these are the 2 errors that can be committed when we are making a decision. And they are normally depicted using symbols of alpha and beta. Alpha is the probability of type 1 error, which is equal to the probability of rejecting a null hypothesis when the null hypothesis is true. And this is normally the alpha level that we normally set in our testing. And beta is used to depict type 2 error, the probability of type 2 error, and is the probability of failing to reject HO when HO is false, failing to reject HO when HO is false. So sometimes it is more convenient to work with the power of the test, where power is depicted as equal to 1 minus beta, which is equal to the probability of rejecting HO when HO is false. That is the power, 1 minus beta. And this is what we want to achieve. So if it is large, the better. That means beta is small. The general procedure in hypothesis testing is to specify a value of probability of type 1 error, which is normally alpha, which is normally we call the significance level of the test. And once that one has been set, normally we don't mind too much about the type 2 error because things just fit into place when the type 1 error is already set. That is the probability of rejecting HO when HO is true. We want this to be very small indeed, so that we don't reject things when they are not supposed to be rejected. So that is briefly about the two questions somebody asked yesterday about data transformation and the power. Let us now go to results. When you look at writing a scientific paper, the result section is very, very, very key. And normally what happens, I will not go in details on what to do and so on, but once you have analyzed your data, we need to understand that the data is telling us something which we need to put in a summarized form. And there are three summarization techniques that most people use: diagrams, tables, and numerical summarization. When we talk of descriptive statistics, these ones are results that we obtain from our analysis, and they can be presented in any of these three forms of summarizing data. So in descriptive statistics, we saw yesterday or today that it simply describes a set of data with summary statistics, and these are normally useful, and we know most of them are the means, the mode, and so on. Dr. Uda talked about it yesterday. These ones normally measure what we call central tendency of the distribution. We have normally percentiles, which show in the percentages the data is falling in. We have numbers of observations or frequencies that have been collected in the field. We also have a measure of variation or dispersion, or sometimes called scatter, of the observations, as well as the units of measurements can be reported. And also under descriptive statistics, we have we can also look at how the data is distributed, and we can look at the skewness, that is how asymmetric it is or how symmetric it is, and also kurtosis, which shows the pickiness of the data. So if we look at the graphs and charts, they are more or less very similar. We normally put them either in graphs or in figures. These are the two main types of graphical presentation of results, research results. That is the line graph. We shall see an example which is mostly useful to display more than one relationship in the same picture. And bar charts, these ones can display simple results clearly. And what I show you in figure 1 gives an example of two bar charts displaying the same data, and they show grain yields for 6 groups formed by a combination of 3 wheat varieties and 2 cultivation methods, traditional and broad type method. This is an example of a bar chart. They are showing the same data. They are showing the same data, where in the x-axis we have the wheat varieties B, C, A, and within each of these wheat varieties we have the groups of the cultivation methods. The same data we can depict it using cultivation methods on the x-axis, and you can see the graph here, the broad bed, and then the traditional methods. And as a scientist, once you have this kind of data, you can explain it briefly, but the figure is supposed to be self-explanatory. You make sure there is a title, the margins are labeled, and there is a key that shows what is blue, what is red, and what is green, and so on. That is about bar charts, but you can see sometimes you can vary what you can use in the x-axis so that you can see which bar chart type can I use to explain properly my objective. So I'm not saying one is better than the other, but it will entirely depend on what you are really trying to explain. What you are really trying to explain. And the same data can be presented in using line graphs. Line graphs. You can see these are line graphs. The blue one is showing B, and the red one is showing C. That is a variety C of the wheat, and the lower one is showing variety A. And you can see clearly there is some interaction, and variety A is always below the others, But when you present it, when you have put wheat as the main variable on the x-axis, you can see it shows the cultivation methods, and the broad bed seems to be showing, always above the traditional one. So these are ways you can depict the same data using the graphs, either the line graph or the bar graph, whichever is suitable, and so on. Then you can also present your data once you have analyzed and you have synthesized it. You can present it in terms of tables, and the information we have in these two tables here, table 2A and table 2B, is the same information, but you can see the orientation and the order seems to bring out the results in a better way in table 2B. So if you don't orient your table very well, you can get into a problem of table 2A, where people will not understand what you are trying to explain, because in a column, people normally look at the results in a column. So you can see when you change the values on the right and the values on the left, you can see this data seems to be better presented, where growth rate is in one column, not across like here. Although it's the same data, but it is not across like in this place here. Once it is arranged like this, somebody can see very clearly that growth rate, Lausanne did very well in terms of growth rate, grams per day, and so on and so forth. supplementation, milk intake, you see water intake and so forth. So somebody can see. And in this kind of a table, if growth rate, there was significant difference between the supplementations, then you can add here the overall mean and the LSD for each of these, and then the CV for each one of these also, and that makes your table complete for presentation. When you have quantitative kind of data, sometimes you have person hours spent weeding per unit area between maize planting and tassel. You can have your data presented in such a manner, but you find it very difficult now to try and explain it. But it should not be. Like here, you have hours weeding maize fields, less than 10 hours, 10 to 15 hours, and so on and so forth. And for the sole crop, the hours are given, and so on and so forth. So this is just a simple way of trying to summarize the data you might be having so that people can see, and you talk a bit about it to explain what is there. Lastly, results of statistical analysis. Sometimes we present p-values. So significant probabilities can either be presented by reference to the conventional level, like as Dr. Uda said, in agriculture, we normally use 0.05, or more informative way by stating the exact probability, e.g. P equal to 0.023. Like if you carry out your analysis in SAS, SAS will give you the exact probability. So there are times you can quote the exact probability, or if you don't want to go that way, you can just use a probability less than 0.05, which means this probability that you obtain from your results is less than the conventional value, is very less than. If you look at it, it's actually less than. So you can present it either with this format or this format. All treatment references referred to in results are normally statistically significant, at least at the 5% level, unless otherwise stated, which means sometimes somebody can state their least acceptable value maybe at 10%. If they don't want to the power to be very high, they are just trying to assess situations and not very much concerned with high precision. If only one or two variables are in your results, then results can be included in the text in this particular format. That is if only two values, like you had an issue with dealing with gender and then you want males or females, you are looking at their weights and so on and so forth. You can say something like the initial weights of 48 ewes in the study had a mean of 34.7 kilograms, which ranged from 29.2 to 38.6 kilograms. That is, you are giving a range, trying to show how spread the data, which gave you the mean of 34.7, is being spread. This same kind of information, because there are just two values, you can also use a simpler way of reporting it by saying the mean initial weight of ewes in the study was 34.7 kilograms. And then in brackets, you can say the sample size and then the standard deviation. The standard deviation can be included with the number of observation or the sample size in the brackets. So these two statements more or less give you the same kind of information. That is where you just have two things to report. You don't need to have a table for it, or you don't need to have to draw a graph for such kind of information. Dr. Uda, I think I can stop there and let the other colleagues to add anything they might be having.
Thank you. Let's give a clap to Maurice. I think we will bring all our questions at the end. We have a challenge, and let me say in advance, because I don't know when I'll go off completely. In case I go off, Professor Owoche, is Professor Owoche there?
I've seen him.
Yeah, he has put his on. Is this on, the one for Professor Owoche? Professor Owoche? Professor War?
Yes, I'm there.
Professor
Yes.
War, that is Jim.
Yes.
Okay,
Yeah.
Jim, now what you do, in case I go off, you take over to coordinate so that people don't just miss direction completely. But I hope I'll still be on.
Okay,
Now,
so I'm next, isn't it?
Yes, you are next. And in
Okay.
case it goes off, you or Professor Ward or even Maurice, any of you can agree and to take it over. But I hope I'll still be on. Now, Professor Woche will give us a typical presentation, and he will make it brief on what narratives we need in the results section to add on from where Maurice has stopped. So, Professor.
Okay, thank you very much. I will present also, augment what Mudeheri has presented, and also add a few, but mine will be a little bit narrative. And the first one is on results. And the main aim of the results or findings of the experiment is to describe to give what has been described in the materials and methods. So whatever you described in materials and methods, how you are going to do it, now is what you have, what you found. Now it's advisable here, the function is to direct the reader to figures or tables that present the supporting data. And you will also be giving a narrative. And remember that the results of this section is the core of your paper, your findings. So under this section, you describe the findings.
Prof, could you
yes.
put your video on? You know, sometimes when we see your face, we can see where you are emphasizing, and and that makes the learners take note.
Fine.
You
can now see me.
Video, not yet. We are seeing the
Unmute the video.
Mine, I've already unmuted. You can't see me?
We can't see you.
We can't see you.
Please, how come I'm seeing myself?
We are the ones to see.
I can see him. I'm able to see Prof.
You are seeing me?
Hey, we want to see you.
No, I'm there.
You.
I think, why don't you put this on the presentation mode? Your screen.
That one is okay, and I'm there. Can you see me?
Continue. My IT expert has just walked out.
Okay.
Yeah, continue.
So remember, this results section is a foundation for discussion. And some authors prefer to put results and discussion together. So once you have decided that, remember you present the results and you discuss at the same time. But in this case, we are just talking about results only. So for each set of experiments, you present data that you analyzed. And remember, we are using the word analyze. Okay? Use subheadings again to direct the readers. And then use past tense and grammatically complete correct sentences. I've used the word complete because sometimes you see in the manuscript, sentences are not complete. And at this stage, you are supposed to pile up or remember all the English you are taught from class 1 to high school up to university. So nobody's going to tell you, we'll just be correcting that English, and it's very frustrating. So when you are writing, avoid the words such as recorded. This is a very common word nowadays and is being misused. And remember, this is a TV language. It's not technical language. Any data that has been analyzed, synthesized, and analyzed, it is no longer being recorded. When you go to the field, you will record your data. When you come back to the office, you synthesize and you give the findings or the observations, but not recorded anymore. Okay, never start a sentence with figures. Please, you don't start a sentence with figures. And then those who work with reagents, you weigh, and if you are told to weigh 3.452 grams, you will never weigh exactly, never, when you use those balance. So you are recommended to use the word approximately. So you can start a sentence with approximately 3.54 grams of this compound was weighed. Okay.
But this is the results.
This is results, yes.
This is the results is not.
Or found. Okay. This is results, I'm sorry. But this should be in the materials and methods, okay? Do not start with tables and figures when you are giving results. You start with the narrative, then give us tables and figures. Again, the results should be presented in an orderly manner, following materials and methods. If you are described the site, you described a particular section, remember, you follow it in the results like that.
So, Prof, when you are at that, so that we were to do this jointly, I want just to add in, as you continue, that remember your figures, your tables. Is going to talk about figures. He's talked about tables. What you are presenting there is a summary. And it is perhaps where people who are interested in your paper want to see values. But your narrative is where you are interpreting your statistical findings. So here you are stating the general trends, the general directions, the general information of your null hypothesis. This variety yielded higher, P is equal to this than that variety. And the range of this thing was from this to that. The details are shown on the table this, such that you don't say the whole story of what has happened and again put it in the table. So your narratives are kind of saying what happened statistically and in general, and then you are referring people to values and trends in your graphs and in your tables. So you don't repeat.
Yes.
Yeah, that the main point is that don't repeat the narratives and talk about them, and again, they are in the table. Both the tools should stand alone. What is read in the text passes a message which stands alone. And the table also of the figure, when you read by itself without reading the text, it also stands alone. Okay, Prof, continue.
Okay, so I think that is good. You have explained that. And just to add, there is a trick. If you are looking at the yield, one is 5 tons, another one is 4 tons, and it is in the table, you don't repeat, but check, you can express as a percent increase. Because if you repeat, it's actually double presentation. So don't also assume that the readers read previous sections, so you need to direct them. Now, the figures, graphs, images, tables, those should be very clear, and they are normally from the data. And they should be very clear to explain your finding. And as Dr. Uda said, they will stand alone, and I should be able to look at the figure like below there, and I draw some conclusion. Okay?
So, Prof, when you are still there, because I don't
Yes.
want to come back, when you are writing to any journal, study very carefully guideline to authors on how the figures should be presented. Tables are normally just generally uniform, but journals are specific about how figures should be. And the figures, professional high caliber journals they strictly tell you to present your figures in black and white. Are you noting that? Black and white. And in that black and white, they will also tell you how the legend will be. Like this figure on the right, you can see those patterns. You can see some things which are triangular for that is what is on top. And you can see the ones which are, and I think they have given the legend there. They've given the legend there. I think there's drought, something I can see. Now, those are things that you don't just draw and throw them. Follow the regulation, the guidelines to authors. If there are trends that you want to see a strong relationship of anything, then you have R square. These ones, I can see they are having the R, the small r, the correlation. And they are saying one of the correlations down there is very strong, the one with 3 stars. Those 3 stars, don't use them anywhere. In scientific writing, the 3 stars means highly significant. P is equal to 0.001. The one which is 2 star, the R which is 8.32, means the relationship in that correlation is P is equal to 0.01. The one which is 1 star, 6.99, means the P is 0.05 in that correlation of those variables that they were looking for. And you can see the data labels to tell you on your far left, the legend is telling you that you can point there, Prof, those legends, they are telling you in those patterns how those things were recorded, which one is referring to what, and how strong were those correlations. And these I think under the table, it will be decoded so that, and under the figure, so that the figure stands alone. Okay, Prof, you can continue.
Okay, so actually I've placed those 2 graphs together to show you how you can draw the graphs. And the one on the left, on my left, is a correlation. And remember, you can do correlation, you get your matrix or the table, or you do correlation by plotting the graphs, and then you get the small r's And you can see the small r, but in italics. And that small r, when you do it in Excel, it will give you a big R. Please get that square root of that. It will give you the small r if you are doing correlation. Okay? So don't write the big R. That's number one. Number two, your presentation is like somebody who is cooking maize and beans. If you are cooking maize and beans, there are various ways of serving it. So the results, you should know how you are going to present it to the reader, and you must present it properly. If you don't do it properly, most manuscripts will be rejected, or you find yourself revising it even 5 times. Now, so the one on the left is correlation. And what I wanted to show here is you must have statistics with it, as Dr. Uda has explained. You don't just plot a graph and you leave. The dotted line is trend line, and then the others are their linear correlation showing it. And probably that person, you can see they had different range, the value here. So you can see some are high here and some are here and others are here. So he decided to plot the graphs together. Now, the one on the left, on the right, is a 3-dimensional diagram, which you can do, and most of us don't do it, but you can do it. And you can see the one axis, X is years, the X prime on the right is locations, and then the other side is hybrid mean. So it's trying to take the 3-dimension and show you how that trend is in a 3-dimension and making a plane over there. So if you have experiments over years across locations and you have yield, remember you can present your data in a 3-dimensional diagram. How you make it, that is the makeup of a scientist. You have to present it nicely for people to understand. Coming to the tables, I can't see the top properly, sorry. It should be the figures there should be clear. Sorry.
Prof, a small thing, these are young scientists.
Sorry, yes.
All journals, come back to the figure. All journals, I think most reputable journals, the figure is named under. You draw the figure and you name under.
Yes.
If you draw these figures in Excel, they come out very well, but they end up with the title of the figure inside.
Yeah.
The same title that you have, figure 1, whatever, you also find that the Excel will tell you what is the name of the chart. So that chart name is also inside. So that is wrong. It is like naming it twice. Yeah?
Yes.
Naming it twice. So the figure is named under, the table is named on top. And sometimes the figure is not fig. In our journal, we used to put it fig, but I didn't see the reason why it cannot be written in full. So we changed, now we put it full name figure, figure 1. Put figure, full stop, then give its name. And then, Prof, you can go to the table.
Okay.
The table is normally named on top, not on
yes.
the figure. The table, you name it on the top. And in our journal, it is using Roman, while figures, you use Arabic numbers. The 1, 2, 3 to 9, the 0 to 9. No, there is no figure 0. It is figure 1 up to 9. Whatever the number, but Arabic numbers, the one we know. But the table, we use Roman. You understand what I mean for our journal. But other journals, you look their guidelines to authors. While on this table, Prof, you will explain, but there is normally no vertical line. So when you find yourself trying to do vertical lines, trying to make any decorations, in all journals nearly, this is how the table should look. So Prof, you continue.
Okay, thank you very much. And the table, you can see the caption on top should be complete and very informative. So if you just write regression analysis, it's not enough. And you can see here, they have written very informative. You get all the information about that table. And this is about regression. And the structure is in such a way that you have the first line on top, then the second line here, and the third one here. Now, you need to check also the format of the journals. Some may be different. But in most scientific journals, you'll find that's how they make. When you come here, the initial stand, it means mean and range is being represented. It's under this. And then mean and range again under this. So all this, you come down here, the units are percent here. So you draw a line to tell us the units here, and it's covering both for the mean and range. Then you have intercept. When you find B, they put it in italics because it's a coefficient of regression. It's not a normal B. If it's a normal B, it's going to confuse the reader, those people who are reading, because it will appear as any other letter here. And you can see there is a footnote there, okay? Footnote, and there you can read down there what it means if you can't write all the words on top here. Just
So,
excuse
Prof,
me 1 minute.
So, Prof, I come in again. I come in again. What we call legend in the figure. Prof, excuse me. I don't know whether when I do this, are you seeing it? I'm just seeing it on my computer. The pointer.
Sorry?
When you are doing figures, you are keen about legend. Even the table has got those footnotes. And these footnotes make the table to stand alone. It explains all those variables that are not written in full, like the B has talked about. So that is when the table is said to be standing alone. You can read it without referring back to the text, and it is complete. Prof, continue.
Okay, and then when you write, you see like the T value, don't just type T and write value, R. You can see there's writing in italics. Anything that is not English, you write in italics. In this case, you are trying to differentiate that letter from the normal alphabet that is used, and it has a meaning. So if you don't do those small things, you'll find the journal will be returning your manuscript for all those corrections. Well, now, coming up here on the figures, it's clear from class 2, you are taught how to write tens, hundreds, and thousands. So you can see here the figures are aligned to the right. You need to align your figures also, because those are the rules of mathematics. And you also decide on the decimal points. How many decimal points do you want to use? So you have to decide from the beginning so that your table can fit nicely. You decide 2, you use 2. You decide 3, you use 3. And the B value here, I suspect they could not use 2 decimal because of, if they use 2 here, some of them will remain 0. So
no,
like this.
Prof,
Yes.
While you are explaining that, I want the scientists, the participants to also digest this. When it comes to the number of decimal places, let them have meaning to you also. Because if you are weighing elephants, and somebody who is weighing, let's say, some insects whose weights are not reaching, they're just in grams. Somebody will have a meaning about 0.45 grams than 1,000.167 over an elephant. It doesn't make a meaning. And even your weighing scale, what you are weighing with, what were the measuring, what was the calibration? In your materials and method, if you are weighing, you can say the precision of your calibration, the precision with which the average machine you are using was graduated up to. What precision could it take? So don't put decimal places that don't make meaning, because they are not adding value. In fact, sometimes they subtract value. And then some journals will tell you the maximum so that you are uniform in whatever you are writing. It looks clean, the way this table looks clean. Okay?
Okay. So the best way to formulate your title, always look at the first on the left, your column, and the top here. Then you should be able to formulate this title. So on the top here, it's about regression, okay? And then you have the area, wherever on the planes. So it's capturing that, whatever is dealing with the biomass and so forth. So you need to know how to formulate your title. Don't be shy from writing, okay? Then you have pictures. Pictures should be very informative, and there must be a purpose. So this, for example, is a section of a maize plant, section of a stem of maize. There must be a reason why they took it to show the cells and so forth, those development of the cells. And you can see they even measured here, those cells and the type of cells. When you are using pictures, some people use plants, you must have a relativity, something to show the size of that object. Here they have already mentioned here. I think they have put the bar there. That's number one, because when you look at an object, sometimes your eyes will deceive you. You think they are big, but they are not. So if you put it in the picture and you put it there, some people used to put a coin that you know, others you can put a ruler next to it, or others you actually put the measurement, or like now they have put a bar there. So you look at the relative to the cell that is exhibited there. And those who take pictures in the field, please don't take your image. Don't put your image where there is science. Unless it is only your hand, you are holding something and it is a procedure. But people are not interested in your image. We are interested in the science. So again, the picture must be very informative. Some may require color if necessary, but don't use color. And in some journals, they refer to them as plates, but nowadays they just use figure, okay? So be very keen on the picture so that you pass your message to the reader properly. I think that is the part for the results that I wanted to present. Is Jack there? Is there any question?
Hello?
Hello?
Prof.
Yes, now you are clear. We can hear you.
Are you done?
Yes.
You are through?
Yes.
Very good. Very, very good. I believe this is a very important part of this presentation, in the sense that when you are giving your results, they are scientific results. If the picture is necessary, these days they used to be called plates. These days you can call them photo, you can call them picture. I think it's general to be called them just a picture. And if they are necessary, they are there. And if they can be shown in black and white, maintain black and white, use the general guidelines. If the color, maybe a disease symptom, is important, or it may be lack of certain chemicals in whatever. If it is important, then you can present it in color, and you explain it in the picture, and perhaps also infer to it in the narratives. The result should be refined in such a way that you don't give unnecessary unsynthesized data. The more you talk statistically in your results, the more powerful, appealing, and winning will be your presentation. So I think we want to lump the questions at the end. May I welcome Professor Owor to also make a presentation, and then we will wrap it up. I think Dr. Mundi, I think, is in. He will give us, we will now want to, these are results. There will be issues of discussions. So in that, Professor Owoche, you will come back, and also Professor Owor, you will also come to that. How do we interpret the data in the discussions?
Okay, thank you, Jack. I hope you can see my few slides. I have the fewest slides this time round. Can you see them?
Yes, yes. It's
Okay.
true that your picture, you can put your video on.
I think it is on.
Oh, but we are not seeing it. I think some people.
James, can you see me?
I can, your video.
Yeah, you can see me.
But now we have seen you before. I mean, personally, I'm not
Or
seeing
I'm seeing
you.
myself.
What is happening? They can see themselves, but
for all you're not visible.
Ah.
Yeah,
Or we see you.
They are seeing me. Are the other participants seeing me?
No.
How do I do it?
No, we don't see you. Moderator. Hello.
I've actually opened my
his
video
computer went off.
and my speaker. Anyway, allow
But
me,
for
if
the
you are
sake
seeing
of
the
time, we
slides,
can
then it's
continue.
okay. I can
Just
proceed.
move on, Prof.
Yeah,
Move
as long
on.
as you can see the slides.
Yes.
Yeah.
Now, I just want to add on to what the others have brought in, and I don't want to repeat because basically the results section are very similar, irrespective whether you are doing hard science or social science. But I just want to add by sharing this that for our case, and I think also for science, you can actually present this section by focusing on either key themes, if you are looking at thematic areas, or look at the hypothesis. You can present your results and discussion by hypothesis, or research questions. And then also you can highlight the most significant and unexpected results that are there. Sometimes we say, don't present things that you are not significant. But for social sciences, if you are hypothesis something and it ends up not being significant, mention it that is counter expectations. And then the last thing is that you are also supposed to be able to relate. We allow relating the results you have if they could be confirming or similar to other results in the past studies that in the same area. So you are trying to reinforce that, yes, similar one, but this is a little bit more, but some indications. So you are allowed to refer create reference, some empirical studies of the similar situation, particularly when you are depicting results in your results section. Now, I can't move down. Then something that I would like just to share besides that is that it's important to note that when I was presenting the methodology section, those methodologies are what is coming to this section. Now, this slide just shows that we have models and estimation methods. These models are used to try to fit our data. And therefore, what you are going to present are actually fitted data into your model. And it comes from the methodological background that you have. And so it means that some of your data points, as you fit, for example, the straight line, this is just a simple regression. As you get the beta coefficients, you are actually trying to fit in between those points. And some of the points are outside your fitted lines. Those are the ones that are captured by the error term. And I think someone presented about, Thierry presented about his issues of heteroscedasticity or variances around your variances in the error terms as you move. You see the errors, some of the variables are outside the line, some are further, some are close. That gives you a picture that there is what we call heteroscedasticity, other than what we usually call homo. Homo means the variability is uniform in the error terms. But if the error terms are variable, they fall far away and the others are closer, in heteroscedasticity. And there's a way you solve it. I won't go into the details of that. But this is just a representation of fitting your data from fitting your data into the models. Now, in the discussion, results and discussion, there are two parts that are key: the interpretation, and which I've talked about it, and discussion. It is important to know that interpretation must focus on what the results mean and how they are reliable. So you are mentioning the results themselves. Discussion, you try to relate now with your research problem or research question or your hypothesis. So that's why I've given, how do you interpret your findings? You must organize your findings more coherent and concise. To the point, you are interpreting X1 relates to this by this percentage, but the p-value is here. I think it was also mentioned. And then you create meaningful figures. There are figures that have been presented just a few minutes ago, and tables. So let the figure to be standalone and the tables to be standalone. That can also be interpreted independent of the discussion, so that someone can see and make even an inference. If you are presenting these works to some people who don't have time to read, or executive who want to read very fast, they'll run to the figures and they'll run to the tables, and they'll make their conclusion whether your work has some results that are useful to them. Also, that charts and graphs need to visualize your data. I think that's why I said I won't repeat. Professor Woche wrote the figures that are on the tables. It should visualize the data if possible to show where the data points are, if possible. I think those are the three key things. In discussion, we expect to relate the statistics meanings that you have come up with from the interpretation into their implication. Basically, the most important thing here is the word implications. What does this thing imply? Okay, what is the implication of the work? 2, what does the data say? What is the data telling you? And that's why, for us, we allow you to reflect to some theory. It's moving some theoretical work or hypothesis or the theory of change, or it is actually against my expectation. That's why in the methodology, I had something called a priori assumption. You assume that age or education will, basically, education will influence adoption of a technology. And then you find it doesn't. So that is actually against your expectation. So the implication is that either something, your data, you can combine with observation to try to conclude and give some inference of why it is against that expectation, or related to similar studies that may have found the same thing that might not be directly into your specific study. So I think those are the things I wanted to emphasize in that. And then I have a few, one or two tables to show. I think Maurice presented something about hypothesis testing. It's not different from socioeconomics. And so we test the t value. I mean, the t, of course, the difference between the estimated and then the actual beta, and then the standard error of the beta. The f value similar, which is an overall estimate of everything. And for non-parametrics, we use the likelihood ratio test or the chi-square test, which is shown there. But however, what I wanted to emphasize here is that the results table should be clear and represented properly. Like now, the table I've presented here reflects the t, the standard error, and to get the t value is very easy. You just you take the coefficient and divide by the standard error, you get the t. That is basically what that hypothesis test tells you. And you are now basing it on 95 confidence level and an error term, an error of 0.05. So as long as you say you make your sampling that you know that you will reject if it is greater than 0.05, then you just accept it when you is within. That means any t value that is significant and p value of more than or less than 0.05 is accepted. Okay. Again, another model similar to just what I've shown there, but here I wanted just to relate how these can be converted into graphs. When you are graphing, for example, or representing the results like this into graphs, you have made the interpretation down there. Maybe for every 1 unit of access to education increases your income by $2. Okay, that's what this one means. But at the beginning, you start at a negative. It doesn't matter because that means the question is, how do you represent this one? You should be able to relate the two. And that's where it reflects. These are all the data, but the figure line tells you that it starts the constant or the intercept is negative. But of course, the regression is leaving other variables out. And that is what is captured by the error term. So the fitted line, consider that the error terms are also part of the regression. Okay. Another results, and I want now to shift from here and now present some of the, just two papers again. Jack, are you there?
I'm there.
Yeah, I just want to present two papers again, not a presentation. Show you two papers again, because most of these things I'm saying have been said by Boris.
And you will share?
Yes, I want to just share them. So that I want Jack to comment on the two papers, because some papers allows you to do the star, but you must provide a legend, like this table now. The stars here are representing the p-values, and it shows that the p-values relate to, I mean, the stars, 1 star, 2 star, 3 stars, relate to some p-values or the significance levels. While some journals may just require you to do a p-value itself and then say significance or non-significant. So that's why I want to share those two. And then lastly, I'll just show you some of the key things. This slide, Jack, and for those who are listening, it is good for us to challenge ourselves as scientists. You are publishing for others to read, read your work. The extent to which people read your work is how good maybe your work is cited. And you can easily check yourselves as you do publications in these search engines. Google Scholar, you can register even today, ResearchGate, Academia, or Science Direct. And I want just to make an example of myself. I don't know how I'm rated there, but please don't bother. I want to click one and see my rating. Try yourself. So you need to publish and check yourself to the what extent your publications are also being. So I'll start with this, and then I conclude with the two papers I say. So I want to type my name, and I cite citations in Google Scholar. And if you allow me, I share this. Let me click on it. Can you see that? Can you see the link?
Yeah, we are seeing the link, yes.
Yes, look at that.
Yes.
Just see where I've typed my name, Georgia Ward Citation in Google Scholar. And then I go to Google Scholar and I click. I'm actually online. Now, do you see? You can know how you are well referenced, and the papers will be there in Google Scholar, for example. And Google Scholar is also very good. And you can actually see citations, high index, H index, and I-10 index, your own analysis of your publications. I'm just encouraging this for those who are going to publish so that you can always be cited as well. Don't publish and hide everything in the shelves. Eh? And if you check carefully, this H index, I want you to look for it, the definition of it. It is actually also used to award people who have actually published in certain areas or rank people, the extent in which they are published. I want to pick it. You want to know the meaning? Sorry, Jack, taking you through this. Eh? And I want to type.
No, but this is a learning process.
I want you to get the meaning of H index. Now, again, I share it. Now, do you see the meaning of H index? H index is an author's level metric that measures both the productivity and citation impact of the publications. Citation impact of your publications. And it was initially used for scientists or scholars. And I want you to take the last one. You want to be recognized. The H index correlates with obvious success indicators, such as a winning of the Nobel Prize. I leave you there to think through about that. So I showed you the Google Scholar. I want to check myself in ResearchGate, just those two. And then I want to share with you that I'm just checking myself. When I go to ResearchGate, I find 70 publications where I've published with others. And reading, people have read my work 26,870, and there are 617 citations. It shows publications and projects. So it shows your work as a scientist. When you're applying something and someone is reading about you, some people will actually go to these sites to be able to check what you have done. And that might even make them make decisions very fast about you. So Jack, I think that's what I wanted to share. And then I want to just share you two papers. Yes. And I want you to comment. These are for you to comment, Jack, in relation to how papers are done. Let me pick this one. Can you see this? Can you see this paper?
Yes.
Now,
who are the authors? You are.
No, I'm an author, but not the first one. I'm a part of the authorship. This is Elsevier. And my interest for this is to see the structure of the paper publication we are talking about in the results section. So allow me to move to the results section.
Yes.
And again, emphasize how the results section is supposed to be organized. And they will be varied. Now, Jack, here is where I want you to be attentive and relate to your journal. So results and discussion. So they start by looking at the general descriptives, okay? And the characteristics of the market outlets. And they picture the market. This is about also mapping. And it includes also geo-referencing the market outlets we did in Kenya here. They capture some pictures. You talked about if you want to include pictures as part of your results, okay? They can be included. You can include geo-referencing as the areas where you went as part of the results, but also capture the economic activities that you are discussing in your results. So again, I don't know, Jack, how you allow it out the journal, but I think it allows for you to present even photos, which, and this is where James was saying, please, you don't have to put your voice there. It's about the economic, it's scientific. You want to explain what is going on. And then I go down to the tables. This is where I wanted Jack to comment.
Yes.
If you check the tables here, these are these. And then we come to the model, the coefficients. So I want you to comment on this table that are stars and where the coefficients are, how the publications can be reflected either in stars or in p-values. Yeah, go on.
Yes, where under the table are the stars explained?
Yes, yes, they are explained. Yeah.
Where are they?
Yeah.
Yes.
You see down?
Yes,
those
I'm seeing.
Double star significant at this, 3 stars
Yeah.
significant at that.
Mudaheri.
Yeah.
Now, there was that confidence interval, confidence limit, which you said, because it is said as 5% confidence, you can explain that confidence limit, and then upon that, you have done you have set your confidence limit, and you have done your ANOVA, and you have come up with these several stars, 1 star, 2 star, 3 stars. For example, this paper says that farmers picking fresh fruits and vegetables, whatever they were looking, that parameter was very highly significant, those 3 stars. It is not the figure, it is not that mean of 0.229 is not what is emphasized. It is the significance that came from that analysis, represented by the 3 stars. Yes. That is what is there. But the confidence interval is significant at 5% level. That 5% level is your confidence limit that you had set for you to do the ANOVA. Interpret it. It's long since I went through such a thing. Maurice?
No, it's just what you are saying, you know.
Yeah.
It means
I think
2 stars.
Yes. Maurice, go on.
Yeah.
I'm just saying, you know, so long as you explain what your stars are, then somebody understands it. You see, like 2 stars in this case, it is 5% level. But in another instance, it will be 1 star, 5% level, and so on.
So George,
yes,
the meaning of stars is the emphasis. What is the heading of that column? What is the
That is
heading?
the coefficients.
The coefficients.
The figures are coefficients.
Yes.
Which are the betas? They are the betas.
Coefficients of contingency.
Yes.
I want the participants, and Mudeheri and George will help me with this. In this, if there's some form of regression which has taken place, trying to get a relationship between the parameters that you are measuring. One of them is farmers producing fresh fruits and vegetables. And in that, you are trying to regress because coefficients come from regressions, isn't it? To get some relationships. So a coefficient is the rate of change, the multiplier that was multiplying your dependent variable.
Yeah, but let me now have to come in and just try to explain this and also relate to what Boris was talking about.
There is a dependent variable.
Yes, the dependent variable is supposed to be there, but in general,
you are saying that that coefficient, that multiplier is so
very significant.
It's not
and it is within the 5%.
Yes,
that significance level or limit. But it means it can be between that 0.05 even 0.001. Okay, that's what the confident interval that Maurice was talking about is. It means that here you are now using the limit, which is 5%. But if you had to present the interval, you would find that it is between some range of that interval. But the limit you have given is within it. And because your limit, this one gives a 3-star or very significant, you give it a 3-star.
Well, I believe we may not want to confuse the students. We may be answering questions which are not asked.
Yes, yeah, you don't have to answer it. I wanted you just to comment on how you would be putting it in your journal, but it's other journals allow this type of work. I can see
but this is okay. What you are saying. These dependent variables, whatever was affecting them, were. I'm using my pointer in my computer. It may not. So the message is clear. As a scientist, don't talk like a journalist. Don't talk just like that. Talk from your statistics. Talk from what somebody else cannot just talk about, because they don't have the knowledge, the power, the mandate to do what you can do. Yeah, if somebody who is not a Professor Ward presents this, is a politician somewhere, and he said that does not belong to him. Yeah. It belongs to you people to be the one telling the world this kind of analysis and the interpretation of the same. I want to appreciate, Professor, you also touched on discussion. And I want to bring back Professor Owoche to talk about discussion. And Professor Ward, you can also add value again.
I think that's... Thank you. I think I've finished the other papers I'll be able to share.
Yes.
With,
you have another paper, this other one? There's a figure there I can see. Is it the same paper?
Which one are you seeing?
The one you have shown, is it the same paper? The one which is on?
This is another paper.
All right.
But I'm just saying I'll be able to share this. It has different, these papers have, based on the journal requirements, they have different presentation requirements for tables. I just wanted to actually, as I conclude, highlight that every journal has table formats and figure formats. And they allow certain mixtures or some are so specific. That's why I was asking Jack to come in and explain. But at the end of the day, the meaning are expected to be the same, irrespective of the form.
Yes.
Thank you, Jack.
Yeah, thank you. So in this one, before you remove it, I think somebody was testing, that's where you are, that regression. You see where the significance, he's calling it significance, but it is P.
It is actually P.
It is P. And P in Professor Woche explained why it must be italics. It is not P of phosphorus, it's P which is probability. And it is italics and it is capital. So you can see below there P00. It means this regression gave some results which were showing differences. At P00, that is a very strong significance. It doesn't, they don't, there's a zero value. It could be maybe zeros, then there will be 1 or 3 or something at some point of the after decimal place. So it means the P, the regression was very significant. Are you getting it, my friends? And when you came here to household size, the significance, P, that was no, it didn't matter. But then it came to education of the head, there is education years, they really differ, highly significant. So in this case, they've decided to put values. But somebody would have just put this where there is 8, you would have put stars. In this case, that could be 2 stars. And the other one on the household size, you would have put NS, not significant. And it will follow that. So it depends on the journal, and even you, some journals can even take both, but it is you, what did you want to stress in your result analysis? What do you want to stress? When you see somebody highlighting those stars and what, he wants to really strengthen the fact that these things were significant. You can see one which is 000 here. Which one is it? If had enhanced communication last season, something like that, it was a very high, that is 3 stars in some other presentations. And the next one, 0.02, will be 1 star. So I want to thank you, Professor Owoche. We can clap for George.
Thank you.
And Professor, and now we look at we look at discussion, what to come out. And Professor Owori, you can come back, but what do you want to come out? Because everything you've done so far up to presenting your results, my friend, all that you have done was soft going. Now where people want to see you and to see the scientist you are, and where you want to challenge people, tell them my work disagreed, my work agreed, or I don't even need to even to quote anybody. I just want you to go home knowing that from now onwards, the choice variety, which has beaten everything that everybody else has done, was nonsense, and mine is the only one that you now take is at your discussion. And you can discuss and even fail to conclude, but you have given people the take-home message from your work. That is the meaning of the discussion. The values people have, results can't explain themselves. Having result, it does not explain itself, it's just a result. But explanation and interpretation is the way you discuss them in the perspective with whatever other people have found. So Professor Ward, I'm laying ground for you. Are you now okay? Professor Woche?
Yes.
Now come on and hammer the point home on this section called discussion. Rarely do papers get rejected because of discussion, but if you don't do it properly, some journals will not take it kind and they will tell you, no, we cannot publish because your results, you have not brought the meaning out of them. It's like you are doing this work and you didn't have a message you wanted to pass. So, okay, Prof.
Thank you very much.
Yeah.
Professor Wara has touched discussion, so you'll find some overlapping information, which is okay. And this is the part that is, in most cases, is difficult for the writers, and they get lost. And the function for this discussion is to answer the question or objectives you had posed in the introduction. It also explains how results support the answers or findings. It explains how answers fit in with the existing knowledge, okay? And in this section, be sure to convey the significance of your work and emphasize unique contribution. It is here where you will be hypothesizing. You will be telling us what you found, interpreted, related with the findings. If it is new, you'll highlight it here. Now, first, just a tip how to write discussion. Remember in the results, you have been writing and you prepared the tables, you write the narrative in paragraphs and you continue. Just to recall what you said you'll analyze, in your case, analysis of variance, you separated the means, then you drew the graphs and so forth. Interpret analysis of variance, interpret regression, interpret correlation. And once you have interpreted that, you go to the next one. You need to give us reasons and relate to other findings. So the trick is take the first paragraph of your result, read it, discuss it. Go to the next paragraph, read it, discuss it, because you have to discuss those results. So you are actually answering or interpreting your results. And in your discussion, you accompany, support, explanation, and defense of answers. So remember, you have to defend your answers, your interpretation, and at this point, you have to relate it to other studies. Do not repeat results in this section. This section is discussion, and if it is well written, there should be no figures being repeated in discussion area. So you explain what is new in your work. You compare with the previously published work. You also give any unexpected finding, discrepancies with others related work, and limitation of methods or study design. You'll be finding some variation. And remember, this is where you'll tell us why. And if there is a limitation, you also mention that these findings are probably because of this, or it's differing with the other one, and you specify the limitations. The importance and significance of your work should come up clearly here, and so that you answer the question. You'll use present tense except when describing previous work, where you'll use past tense. Now, in this section, how you state your English matters, And sometimes you need to check your weakness and break the monotony, because everybody has a weakness in writing. And you'll find yourself repeating or using particular words often. So you need to check that. And that's why somebody else needs to counter check, read your work before you submit the document. Okay. So at the beginning, state with very brief one-paragraph summary that provides the answer to the question and gives main lines of evidence that supports the answer. So you'll state your brief paragraph, you'll state your findings, interpret, and then link it now to other evidence, other documents. The answer can be stated in the first sentence or after one sentence, okay? Then in the middle, include your interpretations of results and generally organize from most to the least important answers. You need to use clear topic sentences at the beginning of each paragraph. Compare your work to relevant studies of others, and I've indicated here, break the monotony of your English. For example, you'll find very many people will write John et al. Reported. Okay, everywhere John et al. Reported. You can restructure those sentences that you don't repeat, because when you write like that, it's exposing the author that you are lacking language of expressing yourself. Okay, then towards the end, you give conclusion. Okay, and in the conclusion, you'll indicate importance of work by stating the applications of all the speculations. So sometimes you may not be able to support your findings, but you can speculate, but you don't have to speculate everywhere.
Okay, I want I want to interject there, Kidogo. The speculation here there are many ways to view it, and an important thing to consider when we are writing. Many people who are carrying out some work, and they had some expectation on what the results should show. So when they come to their discussions, they start speculating something that was not adduced from the evidence from your work. And then you go ahead and make recommendations. Very common, make recommendations on something that was not even part of the question in your study. So speculations are supposed to be some sort of philosophizing for what the implication of this work can be based on the evidence that you have shown. But don't speculate something which is far off, was not really evidence from your results. Prof, I believe you can explain it a little better. I'm a Professor War, if you are there, yeah, and Dr. Mondi. I don't know whether Dr. Mondi you are logged on. If you can explain, even Maurice, sometimes when people come to the discussions, they are saying things which were not evidenced from the results. They were not even part of the objectives. Yeah.
So that's true. And remember, this is where you'll be telling us your new findings. What is new in your work? What is unique in your work that you found? And you have related it to the others, and the other studies, but you find that your work is new, and this is where it will come up. And you can even hypothesize, come up with something new, and this is where you state it. It's not an easy part to write for most people. And if I may say, you can write it 2 days, you may still be writing only 1 page. And you write, you keep on correcting, you write, reframe the sentences, and you check. That is what normally happens. If you don't concentrate, you don't really brainstorm, you may be having a discovery, but you don't realize that you have a discovery. So writing this part is not easy, but you need to think properly, relate, read other work, and then state your discovery. The last paragraph there where there is a conclusion, remember you had a hypothesis at the beginning, and you'll check. Are you meeting your hypothesis? And most people, if they don't, they get worried. You don't have to, because in science you can disagree or prove that a particular that experiment, whatever you are doing, was not working. So you have to report, and it means you'll also disagree with other people what they did if it is related to other research. It is a part that when you are writing, we'll see your language, we'll see your presentation, and we'll see your interpretation. So it's not very easy for most people, but you need to be very well organized, and the discussion should flow up to the end. Dr. Uda, I think I'm done.
Well, now can we give a round of applause to all the presenters, from Maurice to we can give a clap. And now I want to, where are we in the program? We were trying to rush this. I believe, Dr. Mondi, you are in the vicinity. But before you come in, I'm sure we don't have the large numbers that we had before. They are 91. My friend, is it not in? Can I now call upon you to show, by show of hands, some areas where you need clarification? Kevin, I've seen your hand. How many hands do we have? Anybody else other than Kevin? Flora? Beric, I've seen your hand. Anybody else? And please, even if you have to take us back to the slides that you want to refer to, the resource guys are still there. It is for the learning. Some of those questions are the ones that help us to learn even more. So, Kevin?
Thank you, Dr. Oda. I have 4 questions. The first question is on the coefficients.
Yes.
This goes back to Dr. Owoche, Professor Owoche's presentation. The p-value is given in 3 figures. That is the p-value at 0.05, 0.01, and 0.001.
Yes.
Is there an advantage of using those the three different p-values and what advantage does it have over just simply using the 0.05 p-value. The second question, in the presentation given by Professor Woche, I noticed that in the table, the means and the standard deviations are given in separate columns. Can we also give, for example, a mean plus or minus standard deviation, and then at the footnote of the table, for example, we explain it? That question is on the use of figures and tables. Most Q1 and Q2 journals that I've seen will limit the use of tables and figures to 6. How do we choose the most appropriate figures and tables to use? And then the last question is on the discussion section. We've been told that we should follow the materials and methods section and the results section and use that order in explaining in the discussion section. Yet in the last slide, there was a sentence that talked of you start from the most important findings to the least important findings. So that got me confused. Maybe it can be clarified. Thank you.
Can I answer?
Hello? I'm sorry, there was another hand by Beric, so that we take this question, but these are very direct questions.
Yes,
Kevin? Beric, yes.
Yes, can you hear me?
Yes.
Yes, thank you, Prof, for the presentation, and good afternoon, everyone.
Yes.
My question is on the section for discussion. I heard Prof stated clearly that you follow after stating the results, you discuss according to the way you arrange your results. Now, my question is, in a case that you have an experiment conducted both under greenhouse and field, when discussing, should you combine the discussion for both greenhouse and field in a case where you get the same treatments in the field and the greenhouse having same result or giving out same results? So how do you go about it? Should we discuss it the same, combine field and greenhouse, or we separate it, although they give us same results? Thank you.
Although Professor said discussion is the most difficult part to write, I won't agree with him, but I don't want you to go home taking it as if it is a scary thing to do. If you got it correct, it is the sweetest part to write in your work. It's the sweetest part. The most difficult part at proposal is sometimes convincing people in the introduction that you have a case. You have a question, you have a case. So you suffer to really come up with a convincing introduction. But if this is work which is coming from a proposal, probably you have overcome that. And that's why the next obstacle you are seeing is as if it is discussion. But discussion is what you are looking forward to do, to interpret your results. So it's the sweet part to write in a scientific paper. Now, there are these questions that one of them I wanted to help in answering, but let's hear from Maurice, the person who is saying p-values. P-values, whether when you put one as 0.05, 0.01, and the other one, do they have more bearing? And I think the other parts of the questions I did not follow fully. But Maurice, I want you to attempt that first, and then the other resource guys can also add in.
You know what is happening is normally people report the p-values as the computer has given them out. You remember with my result, I said you can sometimes report the exact p-value that you got from the analysis, or you can report that p was less or equal to 0.05. So both ways can still bring out the information that you want to see that what you are looking at is actually significant. Is significant in itself to be included in the model, because when you are doing regression, you are trying to see which variables can be excluded from the model and make no big difference. So the ones which are having very strong p-values, it is saying that they are the ones you can include in the model to describe whatever your y parameter was. So both ways can be used in reporting. If you refer to my last slide where I was saying you can report using the significance level of p less or equal to 0.05 to show that there was significant difference, or you can show the exact p-value that came out from your analysis. Dr. Uda, I think.
Yes, yeah. There were a number of questions. I wanted to say this, Maurice, if you agree. When I opened this ground of statistics and interpretations, I said that in these biological sciences, people have got this, that something that is 0.05 always wrong, or 0.05 always true. Are you getting it? That p 0.05 onwards, it can go to 0.00. You saw some of those in Professor Moore's last examples. P 0.00. That bit, so long as from 0.05, it doesn't now matter. It is already agreed to be significant.
Yes.
What now matters is that when it is highly significant, P000, you don't know when the numeral starts coming in. It just tells you that this is something that you cannot ignore. But it starts from 0.05. From there onwards, then you can find in some work, you really wanted to see that significance and it failed to come, and you don't want to lie. It is P0.06. And you don't want to make it 5 or 0.08. You can still put that p-value, but say this thing, although not significant, but tended. Yeah. So you are being you are being frank. You don't want to fake. You want to say that this thing, don't ignore it. It tended to matter. P 0.08. Are you getting it? But now, the direction is what you have changed. These things were similar, P 0.08, and it tended. Yeah, you're changing the direction of your symbols. It depends on how you are expressing yourself.
Hello.
We can enter the max. We can enter the max.
I'm in meeting.
Yes. Are we together? Maurice, I don't want to confuse people.
Those things.
Yeah?
That's why I'm saying you can use both in your research.
Just hold on. Let me finish this.
Yes. Yeah, Prof.
You can use both.
Yeah.
And but the essence is when you use one, you keep to it.
Yes.
Yes.
Now.
Jack, can I chip in on the issue of the P0 is equal to 0.05?
Yes.
Yes, thank you very much for this opportunity. But Dr. Woche, I think you gave a very good presentation, but I wanted to say that when you started, you said, no, I think it was Maurice who mentioned that for agricultural experiments, it's normally agreed that P is equal to 0.05 is significant. So that is more or less where you can separate whether you are comparing some two probably treatments. You can say this one can pass and this one cannot. But take, for example, in medical research. Medical research, they tend to go higher because of the sensitivity and of course, the accuracy of their results, because they don't want to pass something which again can be detrimental. So in those cases, they tend to go for the highly significant, especially 0.01. So it depends again on the type of research that you are doing. So the sensitivity, but for us who are in agricultural research, I think 0.05 is usually taken to be good enough. But I think for other fields, you can go higher. Thank you.
Can I just comment on that? Remember, there are some fields, they take 0.1. I think Professor Woor can correct me. In socioeconomists, you can see sometimes they indicate 0.1. And 0.05 and 0.001, as Dr. Mondi has said, it depends on the experiment, and there are experiments you have to be very strict. So if you take 0.05, you are committing error. I think Mudeheri explained very well the type of the error you are committing. I think it's error type 2. If you take 0.01 and you are too strict, again, you are committing an error. You may be rejecting what you are not supposed to be rejecting. So for our case, as Dr. Mondi said, we are on 0.05 and below. We still accept that. We use that one. For some other fields, 0.05 might be too liberal. So it depends on your field, and be very careful and decide if you are doing an experiment in a controlled environment, then you don't have to be liberal. You have to be a little bit strict. And you don't use 0.05 or 0.0, be liberal below that, above that. So as a researcher, you need to know your field. You need to know how strict you should be. And remember, if you are too strict, you'll be committing an error. And if you are too liberal, you'll also be committing an error. Thank you. Jack.
Yes. Now, I think any hands? Any hands? The session has been very hard. Now we are at 91. I don't know how many people are on the YouTube, but yesterday.
Jack, I think Kevin's questions were not all answered, and there are some also in the chat. So I think the resource persons can still be given a chance to answer Kevin's questions, even Beric. And there are some on the chat.
Okay, yeah, I can answer some of the questions which were asked.
You know,
the limits and number of tables. The person who asked, remember, when you are doing research and writing is both science and art. How you present your information, you need to know, and how you'll summarize or present them for the reader to digest them. And at the beginning, I said, you can be cooking maize and beans. How you'll present maize and beans on the table vary a lot. You can just boil and put it on the table. Others add salt, Others will add other carrots and all those gadgets, those things. So it is testing you how you are going to present that data. If it is a journal limiting the number of tables, that is their format. Others don't limit. But do you need tables throughout to be monotony? Or do you want graphs? And even tables, how you present, should flow to answer some questions. Okay, and then there was a presentation of tables not standard. Okay, the table, the standard error, you can write the means and write plus or minus standard error. Now, you need to know when to use standard error and standard deviation, first of all. There is a difference. So you can write the mean plus or minus standard error, or put it in a different column. That is entirely upon you, but you may be sometimes restricted with the information you are presenting. So if you want to put all of them there, decide whether you put plus or minus on the means or separate column. Then there was...
Prof, let's see also from Maurice. In your methodology, you must have stated how means were separated. If the means were, you didn't state that, and then you are writing standard error of the mean, it just tells, you're just trying to show that this mean can vary plus minus this. Now, somewhere in your analysis of variance, you must show that there was some significance in terms of the way those values are compared. They differ, there were some differences. So LSD normally bring them to the same base. You can subtract that LSD to any of the values, as Mudaheri explained yesterday, and get to know which ones are different from which. And there are sometimes people go ahead, don't even put any standard error or any value, but put some superscripts to show that these ones were different. So it depends very much on what you want to emphasize. Why are you putting those standard errors? Was it for the purpose of comparison and to know which one is different from the other? And was it your means?
It's freezing. Internet, Jack, your internet. Are you people there?
We are there. Jack seems to have gone.
Okay, I can answer the last question. Greenhouse and field experiment. While he has a problem with the internet.
I think
somebody, hello?
Continue.
Somebody asked about if you have two experiments, greenhouse and field experiment. Remember, in materials and methods, you will also write, you'll start with the greenhouse, then go to the field. So if you started with greenhouse, experiment 1, because some papers you write experiment 1, greenhouse test, experiment 2, field experiment, you write the way the materials and methods is flowing. You don't mix them. Others will separate them to be on different papers. So if they are on the same paper, let it flow the way it is, up to results and discussion. Then conclusion. If you think the two, you can merge the two findings together and relate them fine in the conclusion. So the person who asked about greenhouse and field experiments. I'm done.
Thank you, Prof. It was me who asked.
Yes. Any other question? Oh, Jack is frozen.
Yes, please.
Yes.
In the discussion section, should we follow how we analyzed our results, or should we begin with the most significant result to the least important result?
Follow the presentations of results. You see how you presented the results?
Yes.
You are supposed to be discussing them. If you write results and discussion together, it means you give results, discuss it. Give results, discuss it. So if you separate, then you need to write them and let them flow. You just follow that. And if I may ask you, how long does it take you to write a manuscript after analysis of data? Kevin, how long can it take you?
I beg your pardon, please?
How long can it take you to write a manuscript after you have results?
The discussion section only?
No, manuscript.
It depends.
I've gone out of scene. Are you hearing me?
Yeah, you are lost.
Yeah, I was lost. We are still using now the hotspot. Are there more unanswered questions?
Yeah, I was just answering one question and I asked a question, then you come in. So, Kevin, once you have, it will take you about over a month you are writing, sitting from morning till evening.
Yes.
I don't know how long you take.
I tend to take around the same time, but if I have other assignments from my workstation, it might take longer.
You are waking up in the morning and sitting to write. So 5 weeks.
Yeah, about a month, 1.5 months should be fine with me.
Without any other job.
Yes.
That is what I'm saying. So if you write it within a week and you bring, that will still be trash. It will need to be worked on properly.
Exactly.
Yes.
There are other questions on the chat. Professor Uoche, there are other questions on the chat.
Reactions, where is it? The chronological order form is just a flowing form. You are building it. So that is, somebody is asking there, Jeru. So it is, you are building it the way you build the presentation. You build it in one to the next. For example, you are doing an experiment in Cite, and you are testing maybe some hybrids of maize. So the first thing you describe your site, where you're going to plant. The next thing you describe your hybrids. The next one is experimental procedure, how you do it. Okay, so that is the order. Okay, the next one from HP, I don't know whether it was mine or not. When to use means, minimum, maximum, then mean, N, and SD. Those are descriptive statistics. So if you say you're going to use descriptive statistics, you need to use them there. And there is a paper I presented, there were range, mean, and mode. Okay. Is there another question?
Scroll up.
There is none. Is there one?
There are more. Scroll up, Prof. Scroll up. Yes, there is still Clara Chebet has 2 questions.
I've reached the end.
let me read it for you. I think Clara is asking, just seeking clarification. In disapproving somebody's work in discussions, how do you put it?
That is English now. There is a way you can write those sentences. You see, you write yours, what you found. But you say, however, contrary to somebody, whatever you are. Now that is English expression.
Absolutely.
Okay.
Yeah, she has gone ahead to ask also, does the choice of data transformation affect the CV? Used arc-sign transformation in pest mortality, but the CV was really big. But using the same data with log transformation got CVs of less than 25. How is that?
Arc transformation, whoever asked that, who is that, Chebet or who?
That's Chebet, yeah.
Chebet, check Gomez and Gomez transformation chapter. There is a transformation chapter, Gomez and Gomez. Okay, it explains clearly how you do transformation and why. And the arc transformation, there is a range, especially the percentages Mudeheria said. There is a percent that you need to transform. If you don't, it's going to give you a very big CV. So check if your data is within that range. I think normally it's 30 to 70 and 0 to 30. They say you don't need transformation. And then after that, you need to do transformation. Okay.
Yes, lastly, she has another one. After analysis and output has many parameters like t-value, p-value, etc. Do you include everything in the tables, or you just put parameters of interest, which is your p-value?
Chebet, when you cook Gederi, it is up to you to give what to give us that will use that data to get the findings. So you take, remember we said, I should be able to work out those figures. When you give me that data, I can counter check and calculate and be able to work out when I'm reviewing that, so that I make sure the figures are correct. So if you get the output, put it in such a way that that thing can be verified. Your information can be verified and calculation can be verified. That's what I can say, because ANOVA, if you have ANOVA, you present all ANOVA in one table. You have the common DF, the common column for factors, and then the DF is common. Then the variances, the mean squares are the variances. Then you put probabilities. If you do that for me, I can work out sum of squares, I can work out F values, and so forth. So it's your presentation must be put in such a way that they can be verified.
Ladies and gentlemen, I believe we can carry out this. We have our contacts. We can form a alumni group from this training. We'll see how we can name it, so that we can together in future support one another, and we get to know our progress. And Professor Ward showed us you can even do this Google Scholar to monitor how we will progress from now. And that should be our really focus and motivation, that we can learn from this, spring from this to greater heights in the academia. Now, I think we can still wrap up later on any other issues since yesterday and part of today, but I want to welcome Dr. Mondi to highlight some key issues. I wanted to show you some guidelines to authors in terms of how you do figures, but I think if the time is there tomorrow, we can still come to that. So, Dr. Mondi, I believe you have a few slides on how to write a conclusion and perhaps if there is a recommendation. Some journals, one sentence of implication. A lot of that, the conclusions are found within the discussions and some, but it is the shortest part. It is the shortest part of a scientific paper. And sometimes very difficult if you have many results. You don't know which one you want if you are already limited to 3 sentences. So Dr. Mondi, I think you have digested this. So put it for us in the simplest way possible to make us be able to learn how to write our conclusions. You know, you set your work, you have set your work, you had your objectives, you have gone ahead to answer them through the materials and methods, and you have already put your results, you have interpreted them. Now you want people to say, what do you conclude? What is the message to take home? Are there things, actions that can be, benefits that can come from this, that can be packaged in a recommendation on how to use your work? This is what Dr. Mondi will be able to do in, I think you need 10, 15 minutes. Welcome.
Thank you, Jack. I think I may even need less because you have said it's the social section. I have shared my screen. Can you be able to see it?
Yeah, we are seeing.
Okay, good. Now, if you are seeing it, let me just put the presentation mode. Good. Now, like Dr. Uda has said, writing the conclusion is the last part before you go to bibliography or references. This draws very heavily from the section that we have just been taken through, results and discussion. And therefore, you must relate both. So in the conclusions, what I can say is that the section provides a brief summary of the results and discussion section, but it should be more than just a summary. This section shows how the work advances the field from the present state of knowledge to the next. So in other words, you are trying to tell us that there were some discoveries that you made, or there were unique findings that you had, and therefore your work is different from what other people have done. And that should come out in the results and discussion, but now, you know, more or less blown up in the conclusion section. Again, when I was taking you through the introduction section, I said that when you are writing the introduction section, there were 3 main subsections of that section. And the last one, which was the one that I ended up with, I said that the last section of the introduction should always pose the research question or the objectives. Now, the conclusion which I'm now presenting to you must show how each research question posed in the introduction was addressed, the implications of the findings should be emphasized, and the significance of the work should be explained. So this is the opportunity that you have to go back to your introduction and see if what you set out to do, you got something that you can now say, voila, this was my finding, and therefore this is the take-home message. So it must be very much related to the introduction and also the results and discussion that Professor Ward has taken us through. Again, the goal here is to provide the most general claims that can be supported by evidence. And the key word here is evidence, because you have had your results. You have had your discussion. Therefore, the evidence has already come out. So what you are concluding must be tied to that evidence. You cannot now bring anything else. You cannot now talk about something that was not in the results and was not in your discussion. So that is the evidence that you need to tell us in the conclusion. the conclusion section should allow for opportunistic reading. In other words, when writing this section, imagine a reader who reads the introduction, just skims through the figures and tables in the results section and jumps to the conclusion. Because sometimes, like I think Professor Ward is the one who said, some executives don't want to read a lot. So when he reads the introduction, you have already prepared him what to expect. So he will just flip through the figures and the results. The discussion section is normally too long and very difficult to write, like Professor Woche has said. So he just...
Amwambie Professor Wido waenda hizo marks.
Yes, so he just wants to go to the conclusion and get the main finding. So I think...
Na unasema unampelekea?
Somebody tell Professor Woche that mute his microphone.
Yes, inatakana.
Mute. Dimo Woche, you are... switch off your mic. Professor Woche.
No. Hello?
He's not even hearing.
He's hearing now.
Mute your mic. Yes, mute your mic, Professor Woche.
Yeah, the controller here has stopped it.
I think it's done. Yeah. So the conclusion section should allow for opportunistic reading. In other words, somebody who does not have a lot of time and just wants to reads the title more or less and does not have time for the rest of the body of the paper, can still go to the conclusion and just see what the main findings were. So that is why when you write it, it should be something that can carry the day. Now, the conclusion should concisely provide the key messages the author wishes to convey. It should not repeat the arguments made in the results and discussion, only the final and most powerful conclusion. I'm sorry, I'm using the same word conclusion in the conclusion in the table. But I would like to give an example. James Gimas, who is actually a scientist at Coffee Research, did a very nice paper in a very reputable journal. And I just picked a sentence from his research paper, which he presented in Euphytica. And it read like this: this study is the first attempt to map the R gene conferring resistance to coffee berry disease in Coffea arabica variety, Rume, Sudan. Just look at the catchy word, the first attempt. That means that there was nobody else who had mapped the R gene of resistance that confers resistance to coffee berry disease. That paper was very well read. I think it's one of the masterpieces of the publications that has come out in the recent times at the Coffee Research Institute. So if you write a discussion, a conclusion that gives out, you know, a statement like this, the first time, it gives you that there's evidence to that effect, then it catches the attention of the readers. And while the results and discussion section is often quite long, the conclusion section is generally short. And I think this was well put by Dr. Oda. This is normally the shortest section. It can just be one paragraph and you are done. Conclusion and recommendations can be presented together or separately. But in most journals, we find people writing the conclusion and recommendations together. When presented together, the second goal of the conclusion section is to provide a future perspective on the work which could be the recommendations to the audience or a roadmap for the future. So if you are writing your conclusion and recommendations together, then the recommendation part will be the one that gives the future perspective. What else, what other research work is supposed to be done? Or how do we use your results to advance the science that you have presented? So that part of recommendation usually comes alongside the conclusion in most publications. Conclusion can be presented as a list of major findings. You may not even have to have a narrative. You can just say conclusion, and then in bullets or in numbers, you say finding number 1 was this, number 2 was this, number 3 was this, and somebody picks out those points very easily in a bullet form and knows that now these were your major findings of the research work. A point to note is that without a clear conclusion section, reviewers and readers will find it difficult to judge your work and whether it merits publication in the journal. So reviewers who are reviewing your manuscript and readers who are reading your paper usually would want to know how to judge this work. Was it a good work like the one I've said was done by Dr. James Gimase? So at the conclusion stage, if you write it well, somebody will easily rank that paper and say, this paper was very, very well written because it shows that the findings had good evidence and that you are articulating issues which are new and novel. And therefore, this is something that can give readers something to take home. So pitfalls of writing the conclusion. Some common pitfalls when writing the conclusion are repeating the abstract. The abstract is already a summary of the paper. Now, if you take the abstract to be your conclusion, that should not be the case. The conclusion should only pick those salient issues that your results and discussions have already pulled out. You remember, abstract will have even a bit of the introduction, a bit of the materials and methods, a bit of the results, and so on and so on. So don't bring the abstract to be your conclusion. That will be wrong. Another pitfall is repeating background information from the introduction. So don't cloud your findings in the conclusion of your findings in conclusion with the background information that you already gave us very well in the introduction. Or introducing new evidence or new arguments not found in the results and discussion. You can't put things in conclusion which you did not have in the body of your paper. Don't just bring things from nowhere, from the air, and say, now this is what the paper is saying. We must relate it with your results and discussion so that somebody picking them up can trace them back all the way even up to your methodology and so on. Repeating the arguments made in, you should not repeat the arguments made in the results and discussion. Just pick the findings and those that are, standing out. And that is what you put in the conclusion. Or don't, if it fails to address all the research questions set out in the introduction, then that is also a pitfall. In other words, I've said that at the introduction stage, you post some research questions. And at the conclusion stage, then you should at least strive to address those research questions so that at least the paper is now seen as complete. Because if you post a research question, at the end of results and discussion and conclusion, you leave us hanging, not knowing whether you address them or not, then again, somebody reading the paper, as I've said, will rank you very poorly. So those are the issues that you have to watch out for. And as an example, probably just to give you how a conclusion can look like, a study comparing 2 Indian coffee selections, selection 5A and selection 6, with 2 Kenyan coffee varieties, Will 11 and SL28. So in this study, the conclusion read, the yield potential for selection 6 from India was comparable to the yields of the 2 Kenyan commercial varieties, Will 11 and SL28. Both Indian accessions were outstanding in resistance to coffee leaf rust. You see that? So these accessions that came from India were being compared with the Kenyan ones, but they were found outstanding in resistance to coffee leaf rust. which was only comparable to the resistant real 11 variety. So that outstanding thing is something that tells you there was merit in testing these varieties. And therefore, you can now use those varieties also when you are looking for resistance to coffee leaf rust in Kenya. And in this case also, this conclusion was combined with a recommendation. And therefore, inheritance studies, now the recommendation comes in the next paragraph. Inheritance studies to determine the nature of resistance to coffee leaf rust operating in the Indian accessions is necessary to determine if they are different from those operating on real 11. So you have already established that there is resistance in these Indian accessions, but you are recommending that we need to know the inheritance of those genes so that they can be deployed, if they are the same as the ones in real 11 or different. And it goes further to say, this may provide an opportunity to deploy the genes in the Kenyan varieties as a means of broadening the genetic base of resistance to coffee leaf rust and to counteract the emerging races of rust pathogens in Kenya. So you see, the recommendations now are giving room for more work. In other words, you will be able to know if they are different from the ones we have in the country. And if they are not, then we can deploy them in our varieties so that we can have a broader genetic base. So this is just an example which combines a conclusion and recommendation. And the most important thing is that at the conclusion stage, you bring out what is the new finding, and at the recommendation stage, you give the future prospect. So I think that is the end of my presentation. I promise it will be short. Thank you very much, Dr. Oda.
Thank you, Dr. Mondi. My friend, I've lost this. Thank you, Dr. Mondi. I've gotten it back. I want us to give Dr. Mondi some applause. Welcome questions. Welcome questions. Can I see the hands up? Some people have started dropping out. Can I see some hands up? There, the hands, chat screen is. There are no hands, isn't it? It looks like Dr. Mondi was very, very clear, but I still think we are still at it, and therefore, even at some later stage, we can still ask questions. I want us to finish the day so that tomorrow we dedicate to proposal writing. I'm sure the room will fill to capacity. But for now, I want to go to the next part of this program so that we finish today. We have come to the end of the paper. We have written conclusion, we have written recommendations. Now, another part, which is very challenging, if we cannot finish it today very well, some aspects of it I may cover tomorrow, but I welcome perhaps the youngest resource person amongst the people that we had. They were only to compete with Dr. Mwirigi, but this is Dr. Susan Otieno from Calro Tigoni. And Susan holds a PhD in plant breeding and genetics and plant breeding, genetics and biotechnology. This was done in the University of Michigan in the US, and also for her MSc, she was in a university. Susan, you'll excuse me, you'll pronounce this in Germany, Hanover in Germany. And the BSc was at JQuat. And she is a breeder, a potato breeder within Calro. And there she heads the breeding program in Tigoni. I've said is relatively young. She's just been in service for the last 9 years. And in this, he has been having research efforts on diploid potato breeding, screening and identification of markers associated with resistance to Ralstona Solanocerium. You know that potato, I think, belong to Solanaceae family, and there is a pathogen there. Susan, you will explain this. There is a disease that really affects this potato. And you know, potato, people don't know. In this country, potato and maize, they really compete is which one is the highest staple being consumed. Maize is very loud, but potato is a very important crop in this country. And in terms of the world dishes, it is now almost #1. There they compete a bit with rice and wheat. Now, she has published several papers in 15 in reputable journals, and he has done even a book chapter. Yeah. And this is a very promising upcoming scientist in Cairo. I therefore want to welcome Susan to make her presentation on another very important section of scientific writing called references. And Susan, please, you also cover referencing in the body and how they come to be in the list. And of course, I know you will bring in the softwares that can help even in this. So welcome, Susan. Am I saying you are there? I started, yes, you are there.
Yes.
Welcome.
Can you hear me?
Yes, we can hear you.
Thank you very much.
First, our greetings to guys.
Thank you very
the capital
much.
there? Lilongwe or where? You are in Lilongwe?
Yes, Lilongwe. Yes,
oh,
in Lilongwe.
Okay. I was just guessing. I knew you were in Malawi.
Yes, so we are going to look at the presentation. Today we are talking about citation and referencing. So I'm Susan Otieno. I thank you very much, Dr. Uda, for really giving me a big, presentation and the praises about the work we are doing. So what about citation? So a citation is the way you tell your reader about a certain material in your work. And in most cases, it is advisable that you paraphrase your work when you are citing. So citation gives you, the reader, the information required to find the location or details that source the information that you are working on. So a citation must include a set of parentheses. And without a set of parentheses, one does not have a proper text in Cite. And then with that, you can risk being charged with plagiarism. So it is very important how you do your citation. So why should you cite your sources? This is to give credit to the source, or your audience or readers find out more about the research work, the arguments, the ideas, and the topics that you're dealing with. And this, in essence, will strengthen your work to providing outside support for your ideas. So referencing and citation is very key. And to keep you from failing a paper or a course of being sued for the cases of plagiarism. So it is very important how you do your citations or even how you do your referencing. So there are several tools for citation. So that can help you during your search as you try to get information concerning the work that you are undertaking. So when you find a key paper in your field of research, you should reference it and its reference list for other relevant papers. So you can also search for papers that have cited the key paper. So there are three main sources of citation data that can be used for purposes. So I'll show us these as we go through this work. So So you should find out which resources are best for your literature search and those that will tell your abstract citation database or in the repositories or access tools. So how to keep up to date and how to choose a citation management tool. So there's different citation management tools. You have Web of Science, you have Scopus. Majority of us use Google Scholar. And depending with your discipline, whether you are a social scientist or you are you are an applied scientist. So this depends with whichever you want. In most cases, I encourage most of the readers to use Google Scholar because there are so many information that you can get that. And most of these like Web of Science and Scopus, they are linked to the Google Scholar. So differences between referencing and citing is that in citation, you acknowledge the source of specific part of the article. For example, you are paraphrasing what someone has done, and I will show us as we go along. And in referencing, an entire list of sources which have different references backs the argument of the author. And this also helps in providing at the end of the document or an article. So when you reference, it's just a form of crediting some author's work, and this gives you or another person an idea of how you have borrowed work from someone else. So there are different reference management tools. So there are those that are open source like Mendeley, there's EndNote, there's RefWork, and there is also Zotero. So depending with the students or the audience, I don't know which reference work you use, but I'll try to teach us for the sake of learning Mendeley how it works and the EndNote. Like in my laptop, when I will share my screen, I'll show us what happens. So when you are referencing, this helps you in avoiding duplication, especially when you are showing your references at the end of your work. You've done your discussion, you've concluded, and now you are referencing. You're showing from your work what are the references that you used. So how do you use EndNote or Mendeley? So I had sent us for us to follow the Mendeley where you can download it. So I hope some of the students are already having the Mendeley. And if we have some questions, I'll give us my contact so that in case you have any questions, you are not able to maneuver through, I can always be chatting on you on the sides. So you download Mendeley or EndNote or Zotero or RefWork, and then you follow the tutorial. There is a tutorial that I think I will give us this. You can follow it. Ensure that you download the web importer and in MS Word, because the plugins will enable you to be able to pick your, you insert your EndNotes automatically. And open a Word document. And so using the available citations or imported citation, you can begin to write in your document. So in cases, I'm just giving examples of how you do some in-text citation, or when you are citing more than one article. And this also depends with the style of journal. So in most journals, they will tell you, we want you to use the APA style, or we want you to use the numbered style, or we want you to use Vancouver style, or we want you to use advanced biology style. So when I'll show us in the next page, when you are choosing on the style, pull down menu on the word icon where you will be able to click, and the styles comes automatically. So this referencing just makes your entire document, even if it's of 200 pages, and you're supposed to change the style, you just click in and you are able to change it within minutes. It refreshes and gives the new style that you put. So for
wow. Are you hearing her? Yes, bro.
The voice is gone.
Oh, she has dropped. Maybe she'll reload. She's trying to come back.
She's mute.
She's had to come back. I'm very sorry. This thing came, this part was meant to be presented by Dr. Frida Kimani. She has done it before, but Susan stepped in, although because Frida was caught up in issues of the show. So Susan stepped in to cover, and you can see the challenges being out of the country. We may have dropped her completely. Is she not able to come back? In the meantime, are we able to load somebody else? Because I'm sure we need to get this bit of plagiarism. Oh, okay. It's time to connect.
Dr. Ouda?
Yes.
Probably as we are waiting for Susan, we could try and see whether mine will work.
Yes, I think this is what I wanted to go to. You come in because we don't know how long. We have already gotten the gist of what she is going to present. So can I introduce Daktari here? This is Daktari Marambili. She's originally a vet and currently a PhD, also a PhD holder and a senior lecturer at JQuat. And Madam, there you can see Purity Nguhiu. Purity, Susan is back.
Yes, sorry about that.
I was almost slotting in Purity.
Oh, so
to give us this other very important aspect. Susan, how long more do you need?
Maybe 10 minutes, please.
10.
Yes.
So, ladies and gentlemen, let us be prepared to finish today so that tomorrow we dedicate to proposal writing. So let's aim. Susan, take maybe between 5 and 10, so
sure.
that we finish the day and we dedicate tomorrow to proposal writing.
All right, thank you. Sorry about that. So as I was talking about, if you're doing online citation with digital electronic identifier, that is the DOI, this is how you are supposed to do your referencing. For example, if you see like the work done by Brownie in 2007, this is how you do your referencing. And I think I'll have this PowerPoint, I can share it with the students. And then if your article, in other words, if you have the article from unrelated periodical with no DOI assigned, you can just continue, you choose the URL. And in most cases, they advise the DOI because with this one, it doesn't change. In most cases, they're always very permanent. It's like a permanent identifier. And in other cases, for example, if you have an online scholarly article without a DOI, for example, like author AA and author BB, and you put the date of publication, the title of article, and then you show the volume, and they show the retrieved, where it was retrieved from, the way I've indicated on that slide. So the practicum of how to do the citation, I'm not sure with the audience how many people are using the reference manager, maybe by show of hands from the students. It would be great to know how many are using the the reference managers, and if they are using it, which reference platforms are they using? How many are using?
Susan, you are breaking and going on.
Are you able to hear me, please?
Yes, but sometimes you are breaking. Is
So I was asking from the students or from the, okay, so it looks like majority are using the reference manager. So probably we can engage with them if they have some trouble. For example, like myself, I use the EndNote, and mostly it has a plugin, as I've shown there. So when you open your Microsoft Word, and within that, if you have your reference manager, if it's an EndNote, it's a Zotero, or it's a RefWorks, mostly within your pull-down menu, you can see the add-in for the particular software that you, for the particular reference manager that you use. So maybe if they have questions, then I can answer those.
Are you done? The questions may be at the end of your presentation.
Yes. So yeah, I think
you are done. You are done.
Yes, I'm done. So.
Well, I'm not sure. This is I told you Susan is the youngest here, so you may have understood her more than me, but because this is a very high tech, as we just go manual, what we call analog way of doing referencing.
Yes.
But Susan has given her email there, and I am here as the source that can still get her when we need her. We want to combine both Susan and Dr. here together. So I want to welcome Dr. Purity Nguhiu, who is actually from Kenyatta University, but her background, just like we heard from Dr. Mondi, is a very much homegrown expert. She got a PhD from JKUAT in entomology and parasitology. And then also in the same university, she did her MSc in parasitology, again, and entomology. But the first degree was from the University of Nairobi, where she did Bachelor of Veterinary Medicine. She's a senior lecturer at Kenyatta University, and in the Department of Animal Science. And before that, she has risen through the ranks from, of course, become a lecturer to being a senior lecturer. And before that, she worked with the government up till 2014 as a veterinary officer. And she has done a number of publications. Are you hearing me?
Don't put me in problems.
Yes. Loud and clear. Yes, so you are hearing me. A lot of publication, 15 of them in the peer-reviewed journals, reputable, and book chapters and books, yeah, conference, and many more workshops. And she's very experienced. There are many students that passed through her hands, both over 10 of them in masters. And at the moment, I think she has 4 ongoing PhDs. Has won several research grants. The most prestigious one that I saw in her long list of achievements is being funded even by the university itself through the Vice Chancellor kit, and many more other awards that she has gotten to conduct research. And therefore, I would wish to welcome Purity to give us some tips, some highlights, some insights on this important aspect of scientific writing called plagiarism. Susan has touched on it in terms of we are free. We are free. And with a light touch, Why are lawyers called learned friends? Do you know one of the reasons? One of the reasons when you see a lawyer going to court, they carry volumes and volumes of documents. Yeah, and they refer to them on the spot. They flip those pages and say, here, I'm reading this. And that is why they are called learned friends. For us, we are so learned because we are allowed to cite the work of others, the way Susan has explained the citations, and put it in our document to support our arguments. And that citation there's a way it is done, there's a way it is allowed. When you don't do it in the right way and you are taking people's ideas, it is called plagiarism. You are taking them, you are rewriting a thesis, which is not your own work, you are taking somebody's work, or writing a research paper, it's called plagiarism. There is also self-plagiarism. I think Prof. Doc, if you can also explain self-plagiarism, your own work, you want to replicate as if it is a new work and it is just yourself. Saying that I did this work, you have already published it, now you want to twist it and publish it elsewhere so that you can gain some promotion or gain some mileage in fame because of self-plagiarism. So it's a very important aspect, and these days there are softwares that detect it, and that is why we identified her to bring us into the current ways of detecting plagiarism. So welcome. You can tilt your computer a bit so that your face is seen. Yeah, there you are. So welcome, Prof.
Okay. Thank you very much for welcoming me to be a part of CARO. I do appreciate the opportunity. Thank you also for a very good introduction. Maybe I might be among the older ones in the group, and it is good to join with people like Dr. Susan so that we can also bring in Akna Clara and all the other beautiful girls I've been seeing and hearing them as they were talking. I don't know where my sharing the screen has gone. Are you able to see my screen? I have a very short one.
Yeah, it is not being shared.
I can see it stuck somewhere, so let me try again. I think you need to allow me to share. Because I
think it is coming now, it's there.
Okay.
It is there.
All right. And it's giving you the last slide.
Well, yeah.
All right. So there we are then. From my tour of duty, then I have done a little bit of government work. That was kind of very obvious. And I wanted to just say that when I joined the university, people thought I should have been retiring and going home. But I think it's a good idea to retire and come to the university. And so I was thrown into a very interesting thing. People asked, what is she going to bring into the university? She has served from veterinary officer number 2 all the way to assistant director of veterinary services. So what is she bringing? And I told myself I have a challenge. These are many young people, and teaching in the university can be a challenge because you deal with very many young people. And you also have colleagues to mentor and to work alongside. And so one of the duties that I was given as I talk about plagiarism was to be in charge of the postgraduate students in the department. And the first thing that somebody said as that duty and assignment was being given to me, I'm giving this story as a background and as a way of motivating us that we can learn at any phase in life. If there's a challenge, we can look for a solution. So the first thing that somebody asked is, this one, is she going to manage the computer? That was a very interesting challenge to be given. And so I had to learn many things. So plagiarism may probably not be taught by scientists. And I'm trying to think I am an animal health person, food safety, foods of animal origin, that's my orientation. That's why medical parasitology. So worms are very key, and maybe that's why you picked my work that was funded by Kenyatta University. So when I came in and this is what I was given, I learned that I have to learn new things. And if you're going to be guiding students, then you need to understand the policies that guide scientific writing, both at their proposals, their thesis, and then the work that we can publish. And so I will go through this in a very simple way, because it's also late in the evening, but I hope that you will learn something. And if you are thinking that you couldn't learn a new thing, then you'll go and learn. So plagiarism, what is it? I think somebody has already described it, but I also picked the meaning from the dictionary. It says, it is to steal and pass off the ideas or words of another as your own, or to use another's production without creating the source or crediting the source. It's also to commit literary theft and to present as new and original an idea or a product derived from an existing source. You will notice I don't want to be told I plagiarized. So here is the website, and I'll be sharing these slides so that you can actually look at this for yourself. Then, why is it important that we look at this topic even at this late hour? Because when we plagiarize work, it's an act of academic dishonesty. You are being dishonest. You've just paddied your name. You have picked what was Dr. Ouda's work and placed Dr. Gohio's work. And you know that is not true. Even if it was a journal or even a simple magazine, you are breaching the journalistic ethics. And for publishers, it is also a crime that you just change the title of the book or the name of the book and put in my material and you place it as your own. That is what we are talking about. And even what Dr. Auda said, I also mentioned, it is an old idea. I had done this work earlier. And now because the university criteria says I must publish 4 publications in a peer-reviewed journal, I pick an old document and I twist a little bit, and now I want to create a new journal. I think there must be a way of us discovering that this material has passed through the system before. So that is, what are the methods or types of plagiarism? And here they are. One of them, we call it the clone. You are submitting another person's work, either word for word. You are now not being innovative. Oh, okay, sorry. It is skipped. Let's see whether I can find it again.
Is it at the bottom or anywhere? This is PowerPoint.
It's at the bottom.
Check it at the bottom.
Yeah, but your screen is covering all my work.
I'm seeing it in mine, but in mine it is showing where you can click.
On mine, it is refusing to show because we have brought our faces down. Let's see. And now I have moved your face.
Yeah, you are almost there. Not that. Come to the left. Come. Not, you are not seeing it.
The right one.
Are you able to see that? That's
yes.
better.
Yeah.
All right. Yeah, I have also moved you and me who are hiding the screen to the top. So number 1 is cloning. Sorry.
Yes. Wow.
Yeah, okay. Clone was number 1. Then the other one is cut and paste. That one is very, very common with students. They just go to the library or to the internet and they cut a whole section. And it just contains significant amount of the text that was another person, and they don't do any alteration. Others are a little smarter. They think they look at what are the keywords, and they just look at those, and those are the words they change, but the rest of the document is left the same. Another group of us who could do plagiarism is remix the phrases. So you look at multiple choices and you pick a little bit of information from this document, another small amount from this other document, and you're trying to make them fit together. The other one is number 5, a recycle. You borrow generously from a writer's previous work with no citations. So we cannot know where you are getting your work from. And Dr. Susan was talking about citations. Hybrid is where you combine perfectly cited sources and their copied passages without any citation again. That's how we try to hide it. We hide that we are actually borrowing from other people. The other one is somebody has been using the word cooking maize and beans. You mash up. How do you mix all the copied material from multiple sources and try to do something? Many times when you're working on the online platform, you'll see this document, or you'll see a document sometimes for 404 error. And if you're also checking on your work, you will notice that this error includes citations that are non-existent. So we are there trying to check what professor was showing us today. You are a good scholar, reader, or ResearchGate. We go to the URL you've given or the document you've given. We look for it. It is not found. And that becomes, you are really trying to plagiarize somebody's work or bring us stories that don't even exist. The aggregator, it includes proper citations to sources, but the paper contains almost no original work. So why were you giving us this paper? And you are not telling us it is a systematic review or what we looked at, an analysis that somebody went through this morning. Or you retweet. That includes citations, but you derive too closely to the text of the original work. So you're just changing a little bit in the wording and structure. And you can read a little bit more on the next, on that hyperlink. Now, what happens when you plagiarize work? We may not take you to court. Sometimes we might. Other times, we may not be able to. But seriously, plagiarism can seriously impact your academic or your scientific career as an author. And there are some common consequences that mean either we lower your grade if you're trying to read and you're not, we just discover that your work is plagiarized, or you could even fail the course, have to repeat, get a suspension or something. But for the purposes of scientific writing for publication, the rejection of your manuscript. And that can be very painful because earlier on, somebody said they would take 6 weeks to do a manuscript after they have data. If you, and he was being asked, and he was asked severally, I've been in the whole morning, the whole day, so I have listened to every talk. And he was asked severally, if you just wake up to write this manuscript after you have gotten your data, how long will it take you? And he said, 5 weeks, 6 weeks, if I don't have any other assignment. So what are you saying? 8 hours a day, you are seated to write. And you want to throw all those 8 hours a day for 6 or 7 weeks down the dustbin, because then you say your work is plagiarized. So plagiarism in academia and even in business can actually ruin you or ruin you as a writer. So how do we avoid this? We want to keep tracking our sources as you consult in research. Whatever it is, consult them and keep a track of them. This work was done by so-and-so. You have decided you are doing a case study of Kenya, or you are doing some work that other people have done and you want to critique it. Please keep track of that. Very often, the other thing is you want to paraphrase or quoting your own ideas. Add your own ideas rather than just copy pasting or just pulling it out. Then, of course, it's very important, and this has been emphasized by several speakers today, crediting the original author in an in-text citation and in your reference list. That was the last Susan was talking about. Of course, you could use a checker for plagiarism before you actually submit your work. And I think that is advisable. And I'm going to give a small incident on some work that I have done for the journal that Dr. Uda happens to head. And I think it's the one that's really spearheading this. And I will tell you some of the thoughts that I had about it. So, what are the softwares we have or what is available? All of you are computer literate. If I can be, all of you can be. The Turnitin draft coach, please make sure that you get into this product and learn. It is it's a way of you to learn. So there's the link, I'll share this so you'll have it. Learn with the students every step of how to install it on your Android phone or your computer so that it is available to give you feedback. The Turnitin as a software is very good. It gives you feedback on the studio on what it is that you are asking or what it is that you are doing. It also helps you to correct grammar. So somebody said you have to use all the English that you learned from when you started school up to now. So this app can help you with grammar, and so it becomes very important. Now, why is it important to learn these things and to use them? This is because as a student, you gain more. So as a young researcher, and many of you on this platform are, you gain more and you want to be able to check your work. And then it finally saves on the teacher. If the teacher is going to be checking your English and checking whether you have plagiarized your work and work through the grammar, then it becomes very difficult. And so we want to save each other's time so that we can produce more and do a better job. Now, I want to borrow very heavily from this software, the Turnitin, which is a software that we use in Kenyatta University. And this is the same software that I subjected some papers or some manuscripts. I think you'd call them manuscripts. They hadn't been, officially, academically, we would call them manuscripts before they are out in the journal. One time I was requested to do a work for you. And I want to say that anti-plagiarism, we must have a policy about it. And so I'm heavily borrowing on the KU1, even the example that I will show, even how it works, I will use that. I'm a registered member just by virtue of being in Kenyatta University and having to deal with a lot of student work, publication work. So we need to promote academic integrity or research publication integrity. We need to enforce the values. We also need to ensure that both student and staff, so that would be researchers and all of us, and I think we need to be collaborating a lot more, maintain high levels of integrity, and that our work is original and our research activities remain as such. So we need a policy so that we provide the way in which we shall deal with documents that we think are plagiarized. Now, what I was referring to, and I'm going to show it to you because I have saved a screenshot of that work, was sometime I was requested to just run some papers that you're going to be putting through the journal. And the first thing I asked Dr. Mwirigi, who gave me the assignment, is what level of similarity is admissible? And he didn't really know, so he just told me, run it, and then you let me know the results. And I will say why I am talking about policy at this level, because it became very important. Now, the policy doesn't just come from nowhere, and I'm happy that quite a number of the board members for this journal, our EFJ, are on board in this meeting, so that they can take this seriously that we do require to have a policy for plagiarism so that we can assure ourselves that our papers are. So the legal and policy framework follow every other policy that we have. Intellectual property rights, research policy, what is it that your institution is doing? What does the Constitution of Kenya say? How do we do our repository? Where do we keep our documents? Can I come and know what Susan has done? Can I come and know what Dr. Ouda has done? And do we have that such that we can retrieve that? What is there as far as the Constitution of Kenya says about our research work and research dissemination? Is there anything? We must do that policy in recognition to that document. We also need to look at public officers. What can we divulge? What can we talk about? What can we put it out there? I do have examples I would give of somebody who would go and find a real contaminated, I said, an interest in foods, and particularly foods of animal origin, because I am a vet by trade. And somebody finds this is good science, it's good research, and they find a particular pathogen. And the first thing they want to do is to publish that. How do we safeguard public health, even as we safeguard the integrity of the nation and trade? So we must also look at economic crimes. Those of us who plagiarize, what are we doing? Copyright acts. What information we communicated? What is there in books and newspapers? Science and Technology and Innovation Act. What is there? What is a patent? What is a trademark? And what does the National Crime Research Center research policy and rules and that govern? And then there's this sentence that's always put, even when you are employed or when a deployment is being given to you, you are told, and all other duties that may be allocated to you by your supervisor. So even in law, we also say all other laws that may be passed in Kenya, they will come in and affect your research. Now, how do we confirm that a document is plagiarized? We use softwares, and we could use a lot. We could use one or more search engines, and we've already gone through a few of them today. The web search engines such as Google or Yahoo, and then we'd be able to confirm. We can also use text matching softwares or online services. In the university, this is the software that we use, the Turnitin. It's a text matching service, and it gives us what it is that can happen. So what are the levels of plagiarism? Scholarly work. So we need to establish this. Scholarly work expects the similarity index to be like 16%. If you start telling, and with one document, so I cannot, in my own paper, quote Dr. Ouda's work 5 times, because we want to not have more than 1% of one source being quoted. I hope that is clear. We have a ceiling of 16%, and not more than 1% of that quotation should come from any single source. So those are the benchmarks. And even as we think about our journal and as we think about improving, then this would be my suggestions as we do that. Now, this was a practical, and I thought I would just put it here this way and show when I log in onto my Turnitin, which I can, and I don't want to just now so that we move a little fast. I realize it's beyond 5. So if I just logged in to Turnitin and turn it here, what is it that I'm able to see? I did this screenshot so that you could see what is there on the homepage. It gives me the class ad, the name, the status, and then what time was that work done. So it becomes very, very clear. It remains there in the cloud. Anybody can access it as long as they know how to get it there. And then it tells me on that class, who do I have? What is the information? When did I start loading in that information? When did the date end? What is the summary? And what can I do with that information? And I thought it was good to see that that is how that page comes. Then when we go into, this is completely a student work that I have here. And I ran it, I did a Turnitin test for student work. One of my students, my master students, Gabriel. And it gave me a report. And this is what I'm talking about. It gives me a match of all sources, and it gives me the percentage for each of the references. Now, there are a few things, maybe I would need to be online as far as the Turnitin is concerned, but that will take so long. Yeah, those are the matchings. You can see 1% student papers submitted to Mount Kenya University. Whatever percentage for students given here. And this is what we are looking for. This is quality. He is not quoting only one student. He is bringing in references and citing them properly from a wide range. So he is not just discussing the work of one scientist or one of his colleagues. So I thought this was interesting. There was something I wanted to show on this, maybe, wow. There's multicoloring. I would have to, let me log in because I think this is important, or rather I can just mention it and then we go on to the others. What I wanted to bring out on this bit was on this, when you have a large, just give me a minute, I see whether I'll be able to share my say of on Turnitin directory, and then you don't have to imagine. I'll show you what it is that I am looking at. It's taking longer than I wanted to. Yeah. So let me just go into this so that it is much easier. So I come to the system. There I am. I'll log in quickly because I'm already registered at Kenyatta University. Can you see the screen? Can you see my login?
No.
Hello? Oh,
I cannot see it.
I would need to, okay, I know what
I
need
think
to do.
you would need to share that one also, because
Yeah.
right now we just have your PowerPoint.
Yeah, I'll bring down my PowerPoint.
Yes.
That is what I was fearing, but it is okay. Stop sharing. I am trying to give a new share and it's not giving me an opportunity. And that's why I had tried the screenshot, but I've realized it's not bringing the effect the way I wanted it to bring. Okay, let me try again. Oh, wow. Well, Caro is requesting remote control to share your screen. Are you approving?
Sorry, Doc, you need to stop sharing first and then you reshare the correct screen. stop sharing, and then you share again.
It's not bringing me to that point. And that's what I was hoping to do. Stop sharing.
Maybe you can just continue, and then if you manage later, you can also still show them.
Okay.
Yeah.
All right. Maybe we can look at that later. Now I think I have lost my screen share. Okay. Right. Anyway,
just go back and just share the other one that you are working with. So looks like you have to do them one by one.
Yeah. Okay.
Purity, can you hear me?
Yes, I can hear you. I was just trying to see what I could
I'm being
do.
told that for you to share, you close the previous one. I mean, close the one and then you look at for the previous one. What did you say?
That's what I tried, and I had what I wanted to share, which was my Turnitin there.
But I think you made a wonderful presentation in terms of passing the message. The message is passed that plagiarism is a big issue, and there are ways that we can moderate around it, and there is a way we can detect it so that that danger does not befall you when you submit your paper for a journal or even when you're writing your thesis, because most of these people who are being trained here are also in the process of writing their thesis. And you are there, you are a resource in terms of helping to detect this. I don't know at a fee, but the software is there.
Yeah, the software is there. The institution can get it. That was one of my key messages that I wanted to deliver today. The other key message that I wanted to deliver.
You can go back to your PowerPoint if you are in the last parts of it. If there are some key messages, you can package systematically through that PowerPoint. Yeah.
Yeah. Okay. I was saying yes. So I was saying that on the key.
Have you shared?
No. I'm opening it out. I think it got lost somewhere, but it is okay. It's coming. But I know what I wanted to finish up.
Yes.
Yeah. So I could go on. I was saying the important thing is I would really have wanted also as an organization, CARO, to get a plagiarism policy. That was a key message.
Yes.
And then what I was going to mention about the papers that were shared, and that's why I was trying to go to the Turnitin because they are still there, is that the similarity ranged from 6% to 47%. Now, if you have a document that is 47%, that's what I wanted to show, how decorated it looks. It cannot be your original work, and therefore it's important to take good care of that. So that was something that I thought I wanted to bring out. And then the other one is that, of course, once you have a policy, then you are sure you are able to implement what it is that you want. Then the last bit is that I mentioned that it can be a very expensive thing, and documents that can be plagiarized can include everything, including people's music, people's songs, or even a whole book, and there can be very serious repercussions to somebody. So the repercussions were what I have packaged, and I'll give it back to you as a parting shot. And the parting shot was somebody who decided to use culture, let's go out of science a little bit. And somebody has a nice song. And even in Kenya, that does happen. You have a nice song that you have sung and somebody wants to use your song, either as a campaign message, we are in the campaign season, or they want to promote, use your song to promote. And those can be very expensive ventures. And that was my parting shot, that each one, they don't even have to be scientific, but you could find yourself in trouble for just plagiarizing almost anything. And so in the world of science, you're welcome. Let us keep learning. And I am ready to show us how to operate the Turnitin at a later date. And thank you very much.
A big clap to Purity. A very big clap to Purity and Susan. Each one of us, they happen to be the 2/3 gender rule. So we cannot be blamed that we forgot any other, the gender in the resource people. And to me, that was a very, very stimulating, the last two, and brought us back to the digital age. Plagiarism stresses about policy. There's a software that can be done. There are dangers and the repercussions. In South Africa, where I did my PhD, one of the ministers graduated with a PhD. And after graduation, plagiarism was detected. The repercussions were, he thought it was small, so he resigned as a minister before he could be sacked. And after resigning, it was followed with a court case, and he was jailed. And beyond jailing, there was some big fine because of the person whose work was plagiarized. They took it beyond just jailing was not enough. So there are consequences. And these are very serious things that in our age, now it can be detected. The time when I'm not sure how much of my work can be seen to be plagiarized. Because the way we speak English in Kenya and talk, perhaps it's the same way we write. So you can write and your writing looks similar to another person without intention. So we can open this for discussion. A lot of us have dropped. We are now at 54. When Susan was started, we were around 77. So do we want to quickly discuss? Any hands? Any question?
Yes, Chris. Yes. I have two questions.
Kevin. Kevin and Shadrach, yes.
I have two questions. One,
yes.
Is Turnitin a free-to-use app, or does it include a paid subscription fee? And two, how far does self-plagiarism go? Like, can I use, okay, just how far can it go? Thank you.
Another question by the other gentleman, Odikara, you dropped your hand. Was your question asked by Shadrach? Did you drop your hand? So Purity, my take is that no plagiarism is allowed, even your own. So long as it is plagiarism, it should be zero. You cannot have self-plagiarism. You quote yourself. You're allowed to quote yourself. The work by, and that time you don't say it is myself. The work by Oda this year showed this. You don't say the work I did. Yeah, that work is independent. Yeah, so you can cite yourself, but cite properly, just like an existing work. Am I answering it correctly, Professor Woche? Prof is not with us. Are the other prof in? Who is in? Dr. Mondi? I think majority of the yes.
I am still in. So you even self-plagiarism is not allowed. So I think once you have the Turnitin, you are able to see, as a professor has mentioned, that you need to see that you, for every referencing or citation that you make, that it should not exceed 1%. So even for yourself, there is a way that you are allowed to make reference to your work so that it is not plagiarism. As Dr. Uda says, it is not acceptable.
Yeah.
Yes.
So if there's zero plagiarism,
yes,
that's the best paper.
Oh yeah.
Yeah.
Well, maybe if I just mention what I emphasized on the policy, we don't expect zero. We allow up to 6%.
Yes.
But we don't expect you to quote more than 1% on any one document. So even self-plagiarism shouldn't be, because then you are replicating, you are copy-pasting an old paper, you are remixing it. You remember the 10 ways of plagiarism that I cited? Yes. So you don't want to fall into that. Then I also want to say, I think apart from the matching, where you can learn, where you can, the one that I said, match, so that you learn how to use the platform. I don't think it is free. I think the university pays for this, but once you are in an institution, the pay in the institution may be cheap, and then all of you then are able to use the platform. Thank you.
All right. So the institutions, like Carlo, this is a take-home message. We can see whether if there's something for subscription, our library can subscribe for it. And there may be others that are out there that may be already through some what we say, some people may have sponsored. Yeah, some people may have sponsored some that may be available in for free. But if Turnitin is the one that is working for the institution, maybe Carlo can start from that, from known to probably the unknown.
Dr. Uda, somebody has asked whether Turnitin is just for, that was in the chat, I just saw that, whether it is just for scientific work. And I think the last slide, which I will share as I share the document, was showing, and I even talked about it, it's not just scientific work. Plagiarism can be anything, including music, culture, your books. Yeah. So
when I left South Africa, I came here and got a very famous gospel singer, and it was just plagiarism of somebody Malope in South Africa. But nobody knew, and it went very nicely because I was singing in vernacular. Nobody could tell because it was a very unique way of singing. So plagiarism can be anything, but it can be a political hit. If your song is being used, as we now in the political season, being used, are these people paid? Are these people consulted? I don't know. It's a big thing that maybe our constitution did not even talk about it. So, ladies and gentlemen, I am very thankful for the 50 plus for us who are still here. So we want to close the day by thanking everyone who has participated, and I think you have participated very actively. I still want to thank Carlo management, particularly through Gladys' office that enabled us to assemble and to do this work. Tomorrow, we are dedicating it to learning about proposal writing. So I still welcome all the resource persons, including Purity and Susan, to be in attendance so that some questions will come and we can help in enriching the discussions. The resource people, the main resource people tomorrow will be myself, Dr. Mondi, and Dr. Samuel Mbuku. And at the end of the day, we want the Director General will grace the occasion perhaps to present what is it called? We can get a sample or mock kind of certificate, because we will receive your names and all the course attendants will do certificates which will be presented to you. But I believe the DG, we will get that confirmation. He will at least join us, I'm very sure, probably in the afternoon session. So thanks so much. Have a good evening.
Good evening to you.
Thank you and good evening to you.
Bye.
Good evening to you.
Good evening.
Bye. Good evening.
Bye.